The layout of how a network communicates with different devices is called a topology. And the most common topology is the star topology. In a star topology, all computers are connected to a central wiring point, such as a hub or a switch. And all data on a star network passes through this central point before continuing to its destination. One of the major benefits of this topology is that if one computer failed or if there was a break in the cable, the other computers would not be affected because each computer has their own cable connection. However, a disadvantage of the star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. And this is called a single point of failure. If this happens, the entire network goes down. This is called the bus topology. Now this topology is very old technology and it is not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called BNC, which are also known as T connectors. One of the advantages of the bus topology is that it is fairly cheap and easy to implement. However, a disadvantage of the bus topology is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. If a computer is removed or added, or if the terminators are loose or missing, then the cable would be open and data would bounce back. And this is known as signal reflection. If this happens, data flow would be disrupted. And this is called the ring topology. A ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. This kind of topology is rarely used today. The advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. And this is called the mesh topology. In a mesh topology, each computer on the network connects to every other computer on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers, with 3 connections on each computer, which makes a total of 12 connections for this network. But because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive. So they are rarely used on local area networks or LANs. They are mainly used on wide area networks, like the Internet. In fact, the Internet is a perfect example of a mesh topology. The advantage of a mesh topology is that it creates a high redundancy level, because if one or more connections fail, the computers would still be able to communicate with each other, as you can see on the illustration. Topologies can also be combined with other topologies if needed, and these are known as hybrid topologies. Hybrid topologies can offer the best of both worlds. In fact, a lot of businesses use some form of a hybrid topology to suit their growing needs. The most common forms of hybrid topologies are the star ring network and the star bus network. In a star bus network, two or more star topologies are linked together using a single bus connection. And in a star ring network, two or more star topologies are linked together to form a large ring network. Now, a point-to-point topology is two hosts that are directly connected to each other using a single cable. These hosts could be computers, switches, routers, servers, and so on. So a point-to-point topology is the simplest form of topology there is. A client-server topology is where clients connect directly to a centralized, dedicated server to access resources rather than connecting to each other. Typically, a lot of businesses use this type of topology because instead of having to put all the resources on each computer, which is a lot more work, the administrator can just put all the data on one machine, and then all the clients can access the resources when they need it. So obviously, putting the resources on just one machine is a lot less work than putting the data on multiple clients. It makes the administration a lot simpler. Point-to-multipoint topology is a network architecture that is commonly used in wireless outdoor networks. So what you would have is a central wireless base station, and then there would be other wireless locations around it that connect to the single central location. Now, these other locations would not directly communicate to the other locations. They would all only communicate to the central location. So these wireless locations are commonly called clients. And the central location is commonly called an access point or a base station. A peer-to-peer topology is where all the clients on the network talk to every other client on the network to share their resources with each other. So for example, one computer can share their printer, another computer can share their files on their hard drive, and so on. So there is no centralized server that the clients connect to. They all just connect to each other. And peer-to-peer topologies are simple to set up. You will typically find them in homes and small businesses. Now this is the RJ11 connector, and RJ stands for Register Jack. And this is a 4-wire connector used mainly to connect telephone equipment. But as far as networking, the RJ11 is used to connect computers to local area networks through the computer's modem. The RJ11 locks itself into place by a hinged locking tab, and it resembles the RJ45, but it's a little bit smaller. Now the RJ45 is by far the most common network connector. This is an 8-wire connector used to connect computers to local area networks. And like the RJ11, it also locks itself into place by a hinged locking tab, and it also resembles the RJ11, but it's a little bit larger. Now the RJ48C looks very similar to the RJ45. The difference between the two is that the RJ48C is used with shielded twisted pair instead of unshielded twisted pair. It's primarily used with T1 lines, and it's also wired differently than the RJ45. A UTP coupler is used for connecting UTP cables with RJ45 connectors to each other. This is typically used when running a longer cable is not an option. You just plug one end of the cable into the coupler and then add another cable on the other side. And now you have successfully extended your UTP cable. The BNC connector is a common type of RF connector that is used on coaxial cable. BNC stands for Bayonet Neil Conselman, and it is used for both analog and digital video transmissions, as well as audio. A BNC coupler is used to connect together two coaxial cables with BNC connectors attached to them. This particular coupler is a BNC female-to-female coupler. If you wanted to join two fiber optic connectors, you would use a fiber coupler. Fiber couplers are used to couple or join two of the same fiber optic connectors. The two connectors have to be the same. Now these are not to be confused with fiber adapters, because fiber adapters are for joining two different connectors together, such as an ST to an SC, or an LC to an SC, and so on. So here we have an example of a fiber coupler joining two ST connectors together. Now this connector is called the F-type. Now this is a threaded connector typically used on coaxial cables. These are primarily used by cable providers to attach to cable modems. The F-type hand tightens by an attached nut. This is a USB connector. The USB is very common on desktops and laptops. Many manufacturers make wireless network cards that plug into a USB port. The USB has two different connector types, Type A and Type B. This is the IEEE 1394 connector, and this is also known as FireWire. FireWire is recognized by its D shape. This type of connection is becoming more popular on desktops and laptops, and is commonly associated with attaching peripheral devices such as digital cameras and printers rather than being used as network connections. These are also found on many types of video and multimedia devices. Now we're getting into fiber optic connectors, and this connector is called the MTRJ, which stands for Mechanical Transfer Register Jack. And this is a fiber optic cable connector. It uses a latched push-pull connection, and it has a small form factor used for high packed density. Our next fiber optic connector is called the ST, or straight tip. This uses a half-twist bayonet type of lock, and is commonly used with single-mode fiber optic cable. And our next connector is called the LC, or local connector. And this is also a fiber optic connector. It uses a jack similar to the RJ45. This type of connector is commonly used between floors in a building. And our last fiber optic connector is called the SC, or standard connector. And this uses a push-pull connector similar to audio and video plugs. And like the LC connector, this is also commonly used between floors in a building. The term serial refers to sending data one bit at a time. Serial cables are cables that carry serial data transmission, and the most common form of serial cables use the RS-232 standard, which uses the common D connectors, such as the DB9 and DB25. Now we're going to talk about the difference between UPC and APC connectors. And as an example, we're going to use a group of ST fiber connectors equipped with UPC and APC connectors. When fiber optic connectors make a connection to each other, the point at which the connection is made is not perfect because of the small imperfections of the surfaces. So what happens is at the point where the connectors join, light is transmitted from one connector to the other connector, but at that point where light passes to the other connector, light will reflect back in the opposite direction towards the light source. And as this happens, there is signal loss. This is what happens in a UPC connector. light is reflected directly back. So as technology progressed, a new connector was developed to decrease this signal loss. And this is called the APC connector. The difference between the UPC and the APC is the angle of the tip where the connection is made. With the UPC, the light reflects back towards the light source. But with the APC, with its angled connection, the light doesn't reflect back towards the light source. It reflects back at an angle into the wall of the cable. And as a result, this greatly reduces the signal loss. The term plenum refers to a space in a building where there is open air flow circulation. And this is usually between the drop ceiling and the structure ceiling. Buildings that don't have plenum spaces have air ducts encapsulating the air flow. So as a result, buildings that have plenum spaces where there is adequate open air flow are more prone to fires than buildings that don't have plenum spaces. And because of this, cables that run through plenum spaces must meet certain requirements. First, they must be more fire resistant, and secondly, they must not produce any toxic fumes if they are burned. The IEEE 1901-2013 standard is called Ethernet over HDMI. The HDMI 1.4 specification adds another channel to an HDMI cable for data that will have the capability of network communication. So the connected devices that use this feature will have the ability to send and receive data at 100 megabits per second Ethernet. So in addition to video and audio on a single cable, the HDMI cable will have another ability of Ethernet networking. Sometimes there might be cases in your home or office where you wanted a certain computer in a certain part of the building to be able to access the internet or to be networked. And for whatever reason, network cabling or Wi-Fi just wasn't an option in that part of the building. Maybe because of difficulties in the structure of the building or interference or whatever. So another 1901 standard gave the ability to network using the existing electrical system of the building. Ethernet over power line gives this ability of Ethernet networking over power. So for example, let's say you needed this computer up here to be able to access the internet. But for some reason you can't get any network cables or any Wi-Fi signal to reach that computer. So in this case, we're going to use Ethernet over power. So we're going to need a couple of power line adapters like these. These power line adapters plug directly into a power outlet, and they have a built-in Ethernet port for an RJ45 connector. So one of them plugs into the power outlet next to this computer up here, and then you will connect an Ethernet cable from the network port of the computer and the other end into the power line adapter's Ethernet port. Then the other adapter plugs into the power outlet next to the modem or router down here. Then you would plug an Ethernet cable from the modem or router to the power line adapter. And now Ethernet data will use the building's electrical wiring to deliver networking data to the other power line adapter so that the other computer can access the internet. Today, there are many different cable standards that are used on networks. These cables are categorized and named according to their speed, type, and media. So here is one example. Here is a cable called 10 base T. 10 stands for the maximum speed of this cable. The maximum speed of this cable is 10 megabits per second. Base stands for baseband transmission. and T stands for twisted pair cable. 10-base-2, which is also referred to as thin Ethernet, is a version of Ethernet that uses coaxial cable as opposed to unshielded twisted pair cabling. It has a maximum speed of 10 megabits per second and has a maximum length of 200 meters. Other cable standards include 100-base-T, and this, as the name states, has a speed of 100 megabits per second, which is 10 times faster than 10-base-T. This uses Category 5 UTP cable or higher, and it also has a maximum length of 100 meters. 100-base-T is also known as Fast Ethernet. 100-base-FX, just like 100-base-T, has a speed of 100 megabits per second, but the difference is that FX uses fiber optic cable, where 100-base-T uses copper cabling. It has a maximum length of 400 meters in half duplex mode and 2 kilometers in full duplex mode. And moving on to the gigabit standards, there is 1000-base-T, and this has a speed of 1000 megabits per second. It uses Category 5 UTP cabling or higher, and has a maximum length of 100 meters. 1000-base-TX is similar to 1000-base-T, with the exception that it was supposed to be an easier setup because it only uses 2 unidirectional pairs of wires for communication, whereas 1000-base-T uses 4 bidirectional wires. But 1000-base-TX never caught on, and is known as a failure in commercial implementation. Moving on to the 10 gigabit standard, there is 10G-base-T, and this has a speed of 10,000 megabits per second or 10 gigabits per second. It was developed in 2006, and it uses both shielded and unshielded twisted pair cabling. It has a maximum distance of 100 meters when using Category 6A cabling, or if it's using Category 6, it has a maximum length of 55 meters. Next is 10G-base-SR, where the SR stands for short range. This is a commonly used multi-mode fiber optic specification and has a maximum length of 300 meters. 10-base-ER, or extended reach, and this has a longer range of 40 kilometers using single-mode fiber optics. 10G-base-SW has the same specification as 10G-base-SR, but this is specifically used to operate over SONET, which is synchronous optical networks. Now, a firewall can be either software or hardware. It is a system that is designed to prevent unauthorized access from entering a private network by filtering the information that comes in from the Internet. It blocks unwanted traffic and permits wanted traffic. So basically, it filters the incoming network data packets and determines by its access rules if it is allowed to enter the network. In today's high-tech world, a firewall is essential to every business to keep their network safe. And one way that a firewall controls the flow of traffic coming into and out of a network is through its Access Control List, or ACL. And the ACL is a list of rules on what can access the network. It either allows or denies permission. So as an example, here we have a very simplified ACL with a list of IP addresses that have been allowed or denied on this firewall. So if this IP address tried to get into this network, the firewall will deny it because of the rules that are set in the ACL. But these other IP addresses are granted access because the ACL allows them. Most firewalls come with a default rule of implicit deny. And what that basically means is that the firewall will only allow traffic to enter the network that the ACL specifically says that it will allow. So as an example, if your ACL only has one rule, and let's say that that rule has allowed port number 80, which is web pages, then that means that you'll be allowed to access web pages on your network, but nothing else. You won't be able to use any FTP, HTTPS, or incoming POP or IMAP email because the firewall has implicitly denied those ports. So the only way to access those services is you have to specifically allow them by granting them access in the ACL. So for example, we'll go ahead and add port 25 and port 110 and give those ports access to the network. And now those ports, along with their respective service, are able to go through the firewall, but everything else is implicitly denied. Firewalls come in different types, and one type is called a host-based firewall. And this is a software firewall. This is the kind of firewall that is installed on a computer, and it protects that computer only and nothing else. For example, later versions of Microsoft operating systems come pre-packaged with a host-based firewall, as you can see here. You can turn the firewall on or off if you want, and you can also create exceptions to the firewall based on the application name on the Exceptions tab. And of course, you can always purchase a third-party firewall and install it on your computer. Another type of firewall is called a network-based firewall. And this is the kind that is shown here. A network-based firewall is a combination of hardware and software, and it operates at the network layer. It is placed between a private network and the internet. And unlike a host-based firewall, where it only protects its own computer, a network-based firewall protects an entire network. And it does this through management rules that is applied to the entire network so that any harmful activity can be stopped before it reaches the computers. Firewalls also inspect traffic in a couple of different ways, and one way is called stateful. A stateful firewall monitors all the connections and data streams that are passing through and keeps a record of it. It uses the connection information that comes from the applications and previous sessions and factors that in allowing or denying the flow of data packets. It does a thorough job of protecting a network dynamically. A stateless firewall, on the other hand, does not do a thorough job as a stateful firewall does. A stateless firewall uses an access control list to allow or deny traffic. It does not thoroughly inspect a data packet. It only looks into the header portion of the data packet, and it does not keep a record of previous data packets. Content filtering is a technology that is commonly used in email, and as its name implies, it filters data based on their content and not on the source. This type of filter is commonly used to filter email spam. And another type of filter is called signature identification, and this is used to detect viruses that have a well-known behavior pattern. Certain viruses and malware have a common behavior, and firewalls that use signature identification are programmed to spot this behavior. And once it's spotted, it takes action to block the intruder. Intrusion detection or prevention system is a hardware tool that is typically placed between the internet and the firewall, and its job is to alert and prevent a network from outside attacks. These attacks include viruses, malware, and hackers who are trying to sabotage an internal network. It monitors traffic flowing through a network looking for suspicious patterns, and if it finds any, it alerts the network administrator of a pending danger. The terms 568A and 568B refer to a set of wiring standards developed by TIA/EIA, which is also known as the Telecommunications Industry Association. And these terms define the rules on how twisted pair cables should be wired to RJ45 connectors. And these wires must follow a certain order so that the network can function properly. The 568A standard is wired in this order: white-green, then green, white-orange, blue, white-blue, orange, white-brown, and brown. And the 568B standard is wired in the following order: white-orange, then orange, white-green, blue, white-blue, green, white-brown, and brown. There is no difference in the functionality as to which standard is used. Whether you choose to use the A or B wiring standard, if both ends of the cable are wired using the same standard, then this is known as a straight cable. For example, this cable is wired on both ends using the 568A standard. A straight cable allows signals to pass straight through from end to end. And this is the most common type of cable, and it is used to connect computers to hubs, switches, or modems. Another type of cable is called a crossover, and this cable is created when both ends of the cable are wired using the two different standards. For example, one end is wired using the A standard, and the other end is wired using the B standard. Crossover cables are used to connect two similar devices together. For example, you can use a crossover cable to connect two computers directly to each other without using a hub or a switch. Crossover cables are also used to connect hubs or switches to each other. A rollover cable is created when both ends are wired completely opposite of each other. These are used to connect a computer or a terminal to a router's console port. And a loopback cable is for testing purposes. It's to make a computer think that it's connected to a network. And to make a loopback cable, you connect pin 1 to pin 3 and pin 2 to pin 6. Today, there are 5 different categories of twisted pair cables that you're going to need to know for the exam. The difference between these is the maximum speed they can handle without having any crosstalk. The numbers of these categories represent the tightness of the twists that are applied to the wires. So Category 3 has a maximum speed of 10 megabits per second, and this is an old category that was used on old 10 base T Ethernet networks. Category 5 has a maximum speed of 100 megabits per second, and these were used on 100 base T and TX Ethernet networks. Category 5E is an enhanced version of Category 5, and it has speeds of over 1,000 megabits per second, and these are used on 1000 base T Ethernet networks. And Category 6 also has a maximum speed of 1000 megabits per second, and is also used on 1000 base T Ethernet networks, but it's more of a heavier duty cable when compared to Category 5E. And it's also used on 10G base T networks, which has a max speed of 10,000 megabits per second, but only for cable lengths of less than 100 meters. And last, there's Category 6A, or augmented. And this has a maximum speed of 10,000 megabits per second, and is used on 10G base T networks. And unlike Category 6, this has a maximum length of 100 meters. Unshielded twisted pair is by far the most common type of cable that is used today. It consists of 4 pairs of unshielded wires twisted around each other. The wires are twisted to prevent electromagnetic interference or crosstalk. This type of cabling is mainly used on local area networks. Now, shielded twisted pair is very similar to unshielded twisted pair, except that it has a foil shield that covers the wires. This shielding adds a layer of protection against electromagnetic interference leaking into or out of the cable. This is a coaxial cable. This is used today primarily by cable providers to provide a computer with broadband internet connection. Early on, it was used as a backbone for networks, such as a bus network. Now, there are 2 common types of coaxial cable. The first type is RG6, and this is made for long distances and is commonly used for cable television and internet connection. And the second type is RG59, and this is made for short distances and is commonly used for high definition and high quality video. Now we're getting into fiber optic cables. And here is a cutaway view of a fiber optic cable and a light source. Fiber optic cable uses pulses of light to send data. And as a result, it is very fast and it can span for great distances. Now there are 2 different modes in fiber optics: single mode fiber and multi-mode fiber. Single mode fiber is a fiber optic cable that allows light to enter only at a single angle, as you can see here. So when this type of transmission of light enters at this angle, it can span for great distances. Now this is multi-mode fiber, and the difference between multi-mode and single mode is that in multi-mode, light travels in multiple beams that reflect off the walls of the cable. And unlike single-mode fiber, multi-mode fiber is made for short distances. Sometimes you may need to convert different media types in your network. So if you're running different types of media, such as fiber, Ethernet, or coaxial within your network, well then you can convert and connect all these different types by using a media converter. Media converters allows you to convert to different types of media, such as converting single and multi-mode fiber to Ethernet, fiber to coaxial, and single-mode fiber to multi-mode fiber, and so on. Another standard is called DOCSIS, which stands for Data over Cable Service Interface Specifications. And those of you who have broadband cable internet will recognize this device. And yes, this is your typical DOCSIS cable modem. The DOCSIS modem handles both incoming and outgoing data signals, including internet, video, and voice. The DOCSIS 3.1 specification supports speeds of 10 gigabit downstream and 1 gigabit upstream. A hub is a device that has multiple ports that accepts Ethernet connections from network devices. A hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where data is supposed to be sent. When a data packet arrives at one of the ports, it is copied to all other ports. So all the devices on that hub sees that data packet. There are also two different types of hubs, passive and active. The difference is a passive hub does not require power, but an active hub does require power. Now, a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these addresses in a table. So when a data packet is sent to a switch, it directs it only to the intended destination port. That's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network. Regular switches operate at layer 2 of the OSI model, and we'll talk about the OSI model in a later lesson. But there are other types of switches that operate at higher levels of the OSI model, and one of these is called a multi-layer switch. A multi-layer switch can operate at layer 2 and layer 3 of the OSI model. It's able to interpret layer 3 data similar to a router. And another type of switch is called a content switch. And a content switch can operate at layers 4 through 7 of the OSI model. This type of switch can perform load balancing and advanced filtering, and these switches are also very expensive. Networking devices need electrical power to function, and that's why they have a separate electrical port for a power plug. But some networking devices don't have an electrical port. It's not that they don't need electrical power, it's just that they get their power and data from the same cable, which is through the Ethernet cable. And this technology is known as PoE, which stands for Power over Ethernet. Some networks are designed to be more fault tolerant. For example, in some networks, multiple switches are installed in case a switch does fail. So in a case of a failure, the data can bypass a failed switch and use the others to get to their destination. But a potential problem can happen with this setup, and that problem is with broadcast traffic loops. These loops can happen when there are multiple active paths between the destinations. And when this happens, it can slow down the network because of the excess traffic. So to solve this problem, the spanning tree protocol was created. The spanning tree protocol allows for fault tolerance and prevents unnecessary traffic loops in the network. And it does this by allowing the switches to talk to each other to find if loops are happening in the network. Bridges are used to divide a network into separate collision domains. For example, here we have a network, and this network is segmented into two by a couple of hubs. And if you notice, all the broadcast traffic from the two segments are seen by all the computers on both sides. And this causes unnecessary traffic. So that is where a bridge can be helpful. If you add a bridge to this network, it will reduce any unnecessary traffic between the two segments by filtering the data based on their MAC address. The bridge only allows data to cross over if it meets the required MAC address of the destination, because a bridge keeps a record of all the MAC addresses of the NICs that are connected to it, and it will also block all data from crossing over if it fails to meet this requirement. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the router inspects the packet and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway for a network. Now let's go ahead and demonstrate this. Here we have a private network with its router, and we'll refer to this one as the red network, indicated by the red colored screens on the computers. And over here you're going to have different data packets, indicated by their various colors, and they are going to be entering the red network's router from the internet. The router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network. Now this is a very simplified illustration of how a router works, but I think you'll get the idea. Now here is an expanded view of routers over the internet. There are 4 networks here, indicated by their different colors, and each network has their own router. Now notice how the routers send data. Notice that when a computer wants to send data to another computer on the same network, the data packet never leaves their own network. The router would not let that happen because the router knows what belongs inside and outside their network. But on the other hand, when a computer wants to send data to another computer on a different network, the router allows it. For example, notice how the router on the red network allows the yellow, blue, and green data packets pass by so they can go to their intended destination. The yellow packet goes to the yellow network, the blue goes to the blue network, and so on. And the same goes for all the other networks. A gateway can be defined as a device that joins 2 networks together. They interconnect networks with different or incompatible communication protocols. A gateway, however, does not change the data. It only changes the format of the data. So in simple terms, this illustration is showing how a gateway is transforming a simple signal into something totally different. The circular pattern can represent one network, and as it goes through the gateway, it transforms into a wave pattern which represents a different network. Now this is a CSU-DSU. Now this is a device about the size of a modem, and what this does is that it converts data from a local area network to a wide area network. And this has to happen because the data formats between a LAN and a WAN are different. A network interface card, or NIC, is used to connect a computer to a network. It is basically a circuit board with a network adapter that is installed on your computer. And its job is to convert incoming serial data into parallel data so that the computer can understand it. A NIC provides a constant dedicated connection to a network. And every NIC has its own unique identifier called a MAC address. A transceiver is a device that has both a transmitter and a receiver in the same package. The term applies to wireless communication devices like cell phones and two-way radios. It's basically a term used for any device that receives data, converts it, then transmits the data to another location. A wireless access point is basically a wireless hub that is used by wireless devices. It connects to a wired network and relays data between the wired network and the wireless device for communication purposes. In this illustration, you see a wireless access point wired to a network so that the wireless laptop can communicate with the network. A dial-up modem is a device that allows a computer to transmit data over normal telephone lines. The data coming in from the telephone lines is analog. However, the data in a computer is all digital. So when the analog data comes in from the telephone lines, the modem's job is to convert it into a digital form so the computer can understand it. So that's basically what a modem does. It converts analog data into digital data. And the maximum speed of most modems today is 56 kbps. The IEEE is an international organization for the advancement of technology related to electricity. And they are responsible for a set of standards for a project called the 802 project. And one of these standards is the 802.11 standard, which is wireless. Wireless technology is becoming more and more popular, and today there are 5 wireless standards. There are the A, B, G, N, and AC standards. And here is a chart of the speed, frequencies, and release year for each one. Starting with the first wireless standard, which is 802.11a, which came out in 1999, and the latest standard is the 802.11ac standard, which was released in 2014. Infrared is a technology that was developed by IRDA, which stands for the Infrared Data Association. The term infrared actually means below red. It's a wireless technology where data is transmitted in rays of light, rather than using radio waves. Many companies have now utilized this technology to transmit and receive data in their products. However, the drawbacks of infrared is that it requires a direct line of sight. If any object comes in between the 2 infrared devices, the communication will be blocked. And also, infrared does not work in direct sunlight. If this happens, the communication will be weakened and most likely will be blocked. Bluetooth is a short-range radio that provides a way to connect and exchange information between devices such as laptops, cell phones, and tablets. It operates at 2.4 GHz and is capable of transmitting both voice and data. The latest standard in Bluetooth has a transfer speed of 24 megabits per second and has a maximum range of approximately 100 meters. Here is how you get the MAC address on the Windows computer. The MAC, or Media Access Control Address, is an identifier that every network device uses to uniquely identify itself on a network. So no 2 devices anywhere in the world has the same MAC address. It's made up of a 6-byte hexadecimal number that is burned into every NIC by its manufacturer. The MAC address can contain any number, and it also contains alphabets from A through F. The MAC address is broken up into two parts. The first 3 bytes of the MAC address identifies the manufacturer of the NIC, for example Linksys, Netgear, or Belkin. And the last 3 bytes are a unique number from the manufacturer that identifies each device on a network. In order for network communication to take place, there needs to be a set of standards, and that's why the OSI model was developed. The OSI model describes how information from software in one computer moves through a network to reach software in another computer. And it does this by breaking down this huge task of data communication into 7 different layers, giving control of the data being sent from one layer to another. And these layers are numbered from 1 to 7, starting from the bottom. These layers are the physical, data link, network, transport, session, presentation, and application. This illustration shows how data flows through the OSI model. When 2 computers want to communicate, the data flows down the OSI model, and when the data crosses over the network media, such as the Internet, it flows back up the OSI model to its destination. The top layer of the OSI model is the application layer. And this layer, as you might have guessed, deals with applications. The purpose of this layer is to manage communications between applications. It supports application protocols such as email, HTTP, and FTP. At this layer, data still resembles something that you can actually read. The presentation layer is where data is first converted into a form that can be sent over a network. Data is compressed or decompressed and encrypted or decrypted. This layer is sometimes referred to as the translation layer. The session layer controls the dialogue during communications. It establishes, manages, and terminates the connections between local and remote applications. This layer is also known as the traffic cop because it directs network traffic. The transport layer provides the transfer of data between end users. It's responsible for resending any packets that do not receive an acknowledgement from the destination, ensuring that the data packets were received by the destination. This layer can guarantee that the packets are received. The network layer is responsible for routing the data packet based on its logical IP address. It fragments and reassembles the packets, and it instructs data on how to find its ultimate destination. The data link layer is responsible for sending data to the physical layer. Data packets are encoded and decoded into bits. It handles flow control and frame synchronization. And it's also divided into 2 sublayers: the media access control layer and the logical link control layer. The bottom of the OSI model is the physical layer, and this layer defines the network standards and physical characteristics of a network, such as the connectors, media types, cables, voltages, etc. This layer defines the topology of a network. An IP address is a numeric address. It's an identifier for a computer or device on a network. Every device has to have an IP address for communication purposes. The IP address consists of two parts. The first part is the network address, and the second part is the host address. There are also two types of IP addresses. The first one is the most common one. It's called IP version 4. And a second type is IP version 6. IP version 4 is the current version of IP addresses. It's a 32-bit numeric address written as 4 numbers separated by periods. Each group of numbers that are separated by periods is called an octet. The number range in each octet is 0 to 255. This address version can produce over 4 billion unique addresses. IP address 4 is made up of 4 sets of 8 binary bits, and these sets are called octets. The bits in each octet are represented by a number. So starting from the left, the first bit has a value of 128, then 64, then 32, and so on, all the way down to 1. Each bit on the octet can be either a 1 or a 0. If the number is a 1, then the number that it represents counts. If the number is a 0, then the number that it represents does not count. So, by manipulating the 1s and the 0s in the octet, you can come up with a range from 0 to 255. So for example, the first octet in this IP address is 66. So how do we get a binary number out of 66? First, you look at the octet chart, and you would put 1s under the numbers that would add up to the total of 66. So you would put a 1 in the 64 slot. So now you already have 64, so we need 2 more. So let's put a number 1 in the 2 slot. So now if we count all the numbers that we have 1s underneath them, you would get a total of 66. All of the other bits would be 0s, because we don't need to count them since we already have our number. So this number here is the binary bit version of 66. So we'll put that number down here. So let's do the next number, which is 94. So let's put a 1 under 64, 16, 8, 4, and 2. So if we were to add all the numbers that we have 1s underneath them, we would get a total of 94. And since we don't want to count any of the other numbers, we just put 0s under the rest. So the next number is 29. So let's put a 1 under 16, 8, 4, and 1. And when you add all the numbers up, you get 29. And our last number is 13. So let's select 8, 4, 1, and when you add those up, you get 13. When the internet was first developed, programmers didn't realize how big it would become. They thought that IP version 4, which produced over 4 billion addresses, would be enough. But they were wrong. IP version 6 is the next generation of IP addresses. The main difference between IP version 4 and IP version 6 is the length of the address. The IP version 4 address is a 32-bit numeric address, whereas IP version 6 is a 128-bit hexadecimal address. Hexadecimal uses both numbers and alphabets in the address. So with this type of address, IP version 6 can produce an unbelievable 340 undecillion IP addresses. That's the number 340 with 36 digits after it. So as you might have guessed, IP version 6 is more than enough for the foreseeable future. So as stated before, IP version 6 is a 128-bit hexadecimal address. It's made up of 8 sets of 16 bits, with the 8 sets separated by colons, as you can see here. So in a similar way that we converted an IP version 4 address to a binary number, this is how we convert a binary number to a hexadecimal address. In an IP version 6 IP address, each hexadecimal character represents 4 bits. So we have to convert 4 bits at a time to get one hexadecimal character. So starting from the beginning, we convert the first 4 bits and put those bits up there against our 4-bit chart, which includes an 8, 4, 2, and a 1. So if we count the numbers that we have ones underneath them, you wind up with a 2. So a 2 is the first hexadecimal character in this IP version 6 address. So let's do the next 4 bits and put those under our 4-bit chart. So if we count all the numbers that we have ones underneath them, we have a 4 and a 2. And if we add those up, we get 6. So a 6 is the second hexadecimal character in this IP address. So let's do our next set of 4 bits. And if we add all the numbers that we have ones underneath them, we get a total of 13. But the problem is, since 13 is a double-digit number, we cannot use a double-digit number to represent 4 bits. And that's because in a hexadecimal format, double-digit numbers have to be represented with a single alphabet, which is A through F. So in this case, we have to use another chart for any 4 bits that the sum is 10 or higher. So in this chart up here, if the sum was 10, then we would use the letter A. Or if the sum was 11, then we would use a B. But in this case, our sum is 13. So now for the third character in our binary number, we would put a D. So in our last example, let's do the 4th set of bits. And if we add those up, we get 11. So we have a double-digit character again, which means that we have to convert it to a single character alphabet. So if we look at our chart up here, 11 converts to a B. So the first 16 bits of this binary IP version 6 address converts to the hexadecimal address as 26DB. As stated previously, an IP address has 2 parts. One part is designated for the network, and the remaining is designated for the host. So the way to tell which portion belongs to either the network or the host is where the subnet mask comes in. A subnet mask is a number that resembles an IP address. It reveals how many bits in the IP address are used for the network by masking the network portion of the IP address. So in this subnet mask, the first 2 octets are 255. So if we were to look at this subnet mask in binary form, the first 2 octets would be all ones, because when you count all the numbers in an octet, it will equal 255. Now let's go ahead and add our IP address with its binary form. So the way to tell which portion of this IP address is the network portion is when the subnet mask binary digit is 1, it will indicate the position of the IP address that defines the network. So we'll cross out all the digits in the IP address that line up with the ones in the subnet mask. And when you do this, it will reveal that the first 2 octets are the network portion, and the remaining is the host portion. Here is a chart of the default subnet masks for a class A, B, and C IP addresses. Notice the change of the locations of the network and host portions between them. You should memorize these default subnet mask classes. IP addresses are assigned to different organizations and blocks, and these blocks are divided into 5 classes. But for the exam, you only need to know 3 of them. They are Class A, Class B, and Class C, and you can tell by the number in the first octet which class an IP address belongs to. So a Class A IP range is from 1 to 126. This class supports 16 million hosts on 126 networks. This class is mainly given to large organizations because of the tremendous amount of IP addresses it can give out. And a Class B IP range is from 128 to 191, and this class supports 65,000 hosts on 16,000 networks. This class is given to medium-sized organizations. And a Class C IP range is from 192 to 223. This class supports 254 hosts on 2 million networks. And this class is given to small organizations. You're also going to need to memorize the default subnet masks for each of these classes. Now, if you notice, we skipped over the 127 range. And that's because this number cannot be used for a network, because the number 127 address is reserved for internal loopback functions. Public IP addresses are publicly registered on the Internet, which basically means that if you have a public IP address, you have access to the Internet. But private IP addresses are different. A private IP is not publicly registered, so you cannot directly access the Internet with a private IP. So for example, let's say you have a small business and you need 10 public IP addresses so your employees can access the Internet. Now you could contact your ISP and ask them for these additional IP addresses, but that would be very expensive and unnecessary. So that's where private IP addressing comes in. In private IP addressing, you can create these 10 private IP addresses and just have one publicly registered IP address from your ISP. These 10 private IPs would then be translated into the one public IP so your employees can have access to the Internet. This not only saves money, but it also helps prevent having a shortage of public IP addresses. The RFC-1918 standard created private IP addressing to prevent a shortage of public IP addresses available to ISPs and subscribers. Private IP addresses are typically used on local networks such as homes, schools, and businesses. And these private IP ranges have 3 classes. Class A starts with the number 10, Class B starts with the number 172, and Class C starts with the number 192. The word subnet is short for subnetwork, which means a smaller network within a larger one. Subnetting is basically breaking down a large network into smaller networks or subnets. It's mainly done to make your network more manageable. So for example, let's say you have a company with 3,000 employees, and your ISP assigned you with a Class B IP address with a default subnet mask. So as you know from a previous lesson, a Class B IP address will allow you approximately 65,000 IPs for all your computers. Now you could put all of your employees in one large network, and if you had a small business, then this would be fine. But if you had a fairly large business with, for example, 3,000 computers, then this could be a problem because of traffic issues caused by so many broadcasts. And if a problem were to occur, it'll be very hard to pinpoint on one large network. Or in another scenario, what if your business was scattered into 3 different geographical locations? Then this would also be a problem. So a better way would be to break down your network into smaller ones or subnets. Subnetting is basically done by changing the default subnet mask by borrowing some of the bits that were designated for hosts and using them to create subnets. So a default Class B subnet mask is 255.255.0.0. The first two octets are for the network. The last two octets are designated for hosts. So let's say we want to break down this network into 3 smaller ones. The formula we would use is 2 to the n power minus 2, where n equals the number of bits we need to borrow from the host portion of the subnet mask. So we need to make a custom subnet mask that is equal to at least 3 subnets or larger. So if we put 2 in the place of n, then 2 times 2 equals 4, minus 2 equals 2. So 2 is not going to work because we need at least 3 subnets. So let's try 3 and see if that works for us. So 2 times 2 times 2 equals 8, and 8 minus 2 would equal 6. So borrowing 3 bits will give us 6 subnets, which will be fine because we need at least 3 subnets. So our new custom subnet mask is 255.255.224.0, which will give us 8,000 hosts per subnet. And now our network is broken down into 3 subnets. Every computer on the network has to have an IP address for communication purposes, and there are 2 ways that a computer can be assigned an IP address. It can be done either by using a dynamic IP or a static IP. A dynamic IP is where a computer gets an IP address automatically from a DHCP server. DHCP stands for Dynamic Host Configuration Protocol. A DHCP server automatically assigns a computer with an IP address. And in addition to an IP address, it can also assign a subnet mask, default gateway, and a DNS server. Here we have the TCP/IP properties window open for the network interface card on a Windows machine. And as you can see, this computer is set to obtain an IP address automatically. So when you choose this option and press OK, the computer will send out a request for an IP address. Then the DHCP server will assign an IP address from its pool and deliver it to the computer. Dynamic IP addressing is the best choice because it makes managing a network a lot easier. You can also assign a computer with an IP address manually, and this is called a static IP. A static IP is where a user manually assigns an IP address for the computer, so there is no need for a DHCP server. And this kind of IP addressing is also known as permanent, because unlike dynamic addressing, where the IP address can change automatically, a static IP only changes if the user decides to. When a computer is set to automatically obtain a dynamic IP address, it gets the IP from a DHCP server. But what happens if this computer cannot reach a DHCP server? For instance, what happens if the DHCP server goes down, or if the connection to the server is lost? If this happens, then the computers that are running Microsoft Windows 98 or later, the computer itself will assign its own IP address. This IP address will be in the 169.254.0.0 network. And this type of self-assigned addressing is called API-PA, which stands for Automatic Private IP Address Assignment. Computers running Microsoft Windows 98 or later do this so they can still be able to communicate with other computers on the same network that also have self-assigned IP addresses. If a DHCP server later becomes available, the computer changes its IP address to one that's obtained from a DHCP server. A DHCP server assigns IP addresses to computers on a subnet from its scope. Now, a scope is a group and a range of consecutive IP addresses for computers that automatically gets their IP address from a DHCP server. So for example, here we see a scope of IP addresses from a DHCP service that's built into a Netgear router. The range starts with this IP address and ends with this IP address. These values can be customized to either increasing or decreasing the range. If you wanted a computer on your network to have a specific IP address all the time, you can create a reservation on the DHCP server. A reservation ensures that a specific computer or device identified by its MAC address will always be given the same IP address when that computer accesses the DHCP server. So for example, on this router, if I create a reservation for my computer, the DHCP service on the router will recognize my MAC address and will always give me this specific IP address. Reservations are not typically given to regular computers. They are typically given to special devices or computers, such as network printers and servers that require using the same IP address constantly. When computers obtain an IP address from a DHCP server, the DHCP server assigns the IP address as a lease. So the computer doesn't actually own the IP address. It's actually a lease. And a lease is the amount of time an IP address is assigned to a computer. The lease duration could be a day or more, depending upon the lease settings of a DHCP server. So for example, if I do an ipconfig /all in a command prompt on my computer, you can see that the DHCP service on my router has assigned my computer an IP address with a lease of 1 day. Typically, a DHCP server will automatically renew the IP address for you. So you won't have to do anything or even notice that the IP address is being renewed. You can just continue on like normal and go about your business. As stated previously, when a computer needs an IP address, it will broadcast its request to a DHCP server. And if a DHCP server is on the same subnet as the computer, in other words, if they are using the same IP address settings, then the DHCP server will receive the request and assign the computer an IP address. However, if the computer and the DHCP server are not on the same subnet, in other words, they are not using the same IP address settings, then the DHCP server will not receive the request, because broadcasts cannot go outside their own subnet. So that's where a DHCP relay comes in. A DHCP relay, or IP helper, is a service that is enabled on a router that will relay a DHCP broadcast it receives and forwards it. So now, the computer will broadcast a request for an IP address, and once the DHCP relay on the router receives the broadcast, it will forward the broadcast to the DHCP server, and then the DHCP server will send the IP address back to the computer. Transmission Control Protocol is one of the main protocols used in a TCP/IP network. Now this is a connection-oriented protocol. which basically means that it must first acknowledge a session between the two computers that are communicating. And it does this by using a three-way handshake. The first step is that a computer will send a message called a SYN, S-Y-N. Then the receiving computer will send back an acknowledgement message telling the sender that it has received the message. And finally, the sender computer sends another acknowledgement message back to the receiver. And once this has taken place, data can be delivered. Another important thing to remember about TCP is that it guarantees the delivery of the data. So if a data packet goes astray and doesn't arrive, then TCP will resend it. Now UDP is very similar to TCP. UDP is also for sending and receiving data, but the main difference is that UDP is connectionless, which means that it does not establish a session and does not guarantee data delivery. So when a computer sends their data, it doesn't really care if the data is received at the other end. And that's why UDP is known as a fire and forget protocol, because it sends data and it doesn't really care what happens to it, as this demonstration will show. Another point to remember is that because of the less overhead that's involved of not guaranteeing data delivery, UDP is faster than TCP. FTP stands for File Transfer Protocol, and this is the standard protocol that is used by web users to upload and download files between computers through the internet. So if a user wanted to make their files available to download to other users, all they would have to do is simply upload their files to an FTP server, and then a user can simply download them. Now there are a few ways to transfer files using FTP. You can use your standard internet browser, or you can use special FTP software. It is also important to note that FTP is a connection-oriented protocol that uses TCP for file transfer. TFTP stands for Trivial File Transfer Protocol, and this is a very simple transfer protocol. It is not used to transfer files over the internet like FTP does. It's mainly used for transferring files within the same network, and it does not provide any security during the transfer. And unlike FTP, that uses the TCP protocol for file transfer, TFTP is a connectionless protocol that uses UDP as its transfer protocol. Now, secure FTP is just like FTP, except that it adds a layer of security. The data using secure FTP is actually encrypted using secure shell during data transfer. So no sensitive data like passwords are sent in clear text. SMTP stands for Simple Mail Transfer Protocol. Now this, as you might have guessed, is the protocol that is used to send email. A good way to remember this is by looking at the acronym SMTP and translating that to sending mail to people. SMTP uses the TCP protocol, and as you know by now, it is connection-oriented. So if an email you send does not reach its destination, you'll get that familiar mail delivery error in your mailbox, informing that the email you sent failed. Where SMTP is used for sending email, POP3 is the protocol that is used for receiving email. Whenever an email arrives at your mail server, you can retrieve it using the POP3 protocol and download it to your computer. The main characteristic about POP3 is that all it does is grab the email from the mail server and downloads the email to your computer. It does not sync any email or folders from the mail server and your computer like IMAP4 does, which we'll talk about next. It strictly downloads the email. And typically when your email application using POP3 retrieves the email from the mail server, the email is removed from the mail server, unless you specify in your email application to keep a copy on the mail server. POP3 is commonly used with email applications such as Microsoft Outlook. IMAP4 is another protocol that is used for receiving email. IMAP4 is similar to POP3 because they are both used for retrieving email from a mail server. But IMAP4 has better features. With IMAP4, you can access and manage your email on the server from your local computer. So if you wanted to read your email and keep a copy of it on the server, IMAP4 will allow you to do just that. And unlike POP3, IMAP4 syncs your email and your email folders from the mail server with your computer. And IMAP4 is also commonly used with Microsoft Outlook. HTTP stands for Hypertext Transfer Protocol. Now this is probably the most widely used protocol in the world today. HTTP is the protocol that is used for viewing web pages on the internet. So when you type in a web address, for example google.com, you'll notice that HTTP is added at the beginning of the URL. And this indicates that you are now using HTTP to retrieve this web page. In standard HTTP, all information is sent in clear text. Now normally this would be okay if you were just browsing regular websites. But if you were at a website where you had to enter sensitive data, such as passwords or credit card information, then this would be a problem as far as security. HTTPS stands for Secure Hypertext Transfer Protocol, and this is HTTP with a security feature. HTTPS encrypts the data that is being retrieved by HTTP. So for example, if you wanted to go to your bank's website to check your account, you will notice that an S will be added to the HTTP in the web URL. And this indicates that you are now using HTTPS and have entered a secure website where sensitive data is going to be passed, and that data needs to be protected. Some other examples where HTTPS is used would be like email servers or e-commerce websites. Telnet is a terminal emulation program that is used to access remote servers. It's a simple tool that runs on your computer, and it will allow you to send commands remotely. And because it only sends commands and not graphics, it's very fast. But the drawback is that it's not secure. All commands are sent in clear text. So today, Telnet is mainly used to access devices within a local network and not on the internet. Now, SSH or Secure Shell is a better alternative to Telnet. Secure Shell protects the data from being attacked or stolen as it's being transferred over a network. So for example, if you were sending sensitive data like a login and password, a potential hacker could be listening and steal the data. And that's the reason for Secure Shell. Secure Shell acts like a secure tunnel that forms around the data transfer and protects it from potential threats. ARP stands for Address Resolution Protocol, and this is a protocol that is used to resolve IP addresses to MAC addresses. Whenever a computer needs to communicate with another computer on the network, it needs the MAC address for that computer. So for example, let's say a computer wants to communicate with another one. Now it will first look at its internal list called an ARP cache to see if the targeted computer's IP address already has a matching MAC address in its table. Now if it doesn't, it will send out a broadcast message out on the network asking which computer has the IP address. And the computer that has the matching IP address will respond back informing that it has the IP it's looking for. Then the original computer will ask for their MAC address, and then once it receives it, the communication will take place between the two. Now let's go ahead and see a demonstration of this. Now this is called RARP, which stands for Reverse Address Resolution Protocol. And as you might have guessed, this is just the opposite of ARP. It's used to resolve MAC addresses to IP addresses. NTP stands for Network Time Protocol, and this is an internet standard that is used to synchronize the clocks of computers with the U.S. Naval Observatory master clocks. This protocol runs on each computer, and it sends out periodic requests to the server to make sure the time is in sync. SCP stands for Secure Copy Protocol, and this protocol simply uses secure shell to safeguard data as it's being transferred over a network. And this is called Simple Network Management Protocol, and this is a protocol used for network management. It's basically used for collecting data from various network devices, such as routers, printers, and servers. When data is sent over the internet to your computer, it needs to know how to accept it. And your computer accepts this data using ports. And these ports are categorized by two protocols, TCP and UDP. Now a port is a logical connection that is used by programs to exchange information. And these ports have a unique number that identifies them. The number ranges from 0 to 65535, but for the exam, you only need to know a few of them. So here is a chart of the ports that you need to know for the exam. Some of these ports are very common and are used every single day, such as port 80, which is used for bringing up web pages on the internet. Another one is port 443, which is used for logging into secure web pages that require a login and password. And another common one is port 25, and this is used for sending email from an email application such as Microsoft Outlook. DNS stands for Domain Name System. Now this resolves domain names to IP addresses. In the world of networking, computers don't go by names like humans do. They go by numbers. So if you type in a web address in your web browser, DNS will transform the name to a number, because all computers know are numbers. So for a demonstration, when you type in yahoo.com in your web browser, the DNS server will search through its database to find a matching IP address for that domain name. And when it finds it, it will transform that domain name to the IP address of the Yahoo web server. So DNS basically works like a phone book. When you want to find a phone number, you don't look up the number first. You look up the name first, Then it will give you the number. Now WIN stands for Windows Internet Name Service, and this is used on NetBEUI networks. This service is similar to DNS, and as you recall, DNS resolves domain names to IP addresses, but WINS resolves NetBIOS names or computer names to IP addresses. So if you wanted to communicate with another computer on the same network, you would do so by using the computer's name, and then the WIN server will resolve the name to the IP address of that computer. This is called Network Address Translation, or NAT, and this is a service that is typically used in routers. And this is used to translate a set of IP addresses to another set of IP addresses. So for example, here we have a private network, and it's using a set of private IP addresses internally. Over here we have the router with its public IP address, and this router is running the NAT service. If a computer in this network wanted to communicate over the internet, it needs to translate its private IP address to the internet's public IP address. And this goes both ways. If a computer on the internet wants to communicate with a computer on this private network, then the public IP address needs to be translated to the private IP address for that computer. Another version of network address translation is called PAT, which stands for Port Address Translation. Now this translates IP addresses based on port numbers. Each computer in a private network is issued not only a unique IP address, but they are also issued a unique port number. This is done so that external data packets from the internet knows which computer on the private network it wants to talk to. So for example, if a device outside this network wanted to communicate with a computer on this private network, the IP address along with its port number will be translated by PAT to find the correct computer. SNAT stands for Static Network Address Translation. And as you recall from a previous lesson, NAT translates a private network's IP addresses to a public IP address. So in this example here, these private IP addresses will be translated to this one single public IP address, and vice versa. So what SNAT does is that it can link a public IP address with a private IP address permanently. And this is useful when a computer or server needs to be accessed from outside the network. For example, if one of these devices here was a mail server. Now, a proxy service is similar to your web browser. Whenever you look at a web page, your web browser will store that web page into cache. So at a later time, if you were to look at that web page again, your browser retrieves it much faster because it doesn't have to download the contents of that web page all over again, since it's already stored in your computer. And a proxy server does the same thing. So for example, if a company uses a proxy server, whenever a user wants to retrieve a web page, the proxy server will retrieve the web page from the internet on behalf of the user, and then it will store that web page into a centralized cached database. So if another user on a different computer goes to a web page that has been stored in the proxy database, the proxy server does not have to go out on the internet to retrieve the web page. It can simply retrieve it from its database and send it to the user. So a benefit of using a proxy service is speed, since web page retrieval is much faster. Another benefit is that it saves bandwidth, because a proxy server reduces the need to go out on the internet. And finally, it provides security, because it reports what web pages are retrieved to the network administrator. Remote Desktop Protocol is a technology from Microsoft to access a remote computer's desktop. RDP is based on Microsoft Terminal Services, so if a user wanted to access another computer, the user can simply type in an IP address along with the proper credentials, and then the user can have the remote computer's desktop displayed on their own computer screen. When you have a lot of computers on a network and they're all sending data, the potential for collisions is present. And when you have collisions, data communication is lost. So that's why they developed a protocol called CSMA-CD, which stands for Carrier Sense Multiple Access Collision Detection. And this is the access method used on Ethernet networks. And this method works by each computer first sensing if the wire is idle. And if it is, it sends its data, therefore avoiding any collisions. But if you have two computers trying to send data at the same time, a collision will happen. And if a collision happens, the computers will wait a random amount of time and retries to send their data. CSMA-CA stands for Carrier Sense Multiple Access with Collision Avoidance. And this is the access method used for carrier transmission in wireless networks. Now this method is similar to the CSMA-CD, except that when a computer wants to send its data, it first sends out a small data packet to make sure that the channel is clear before sending out its main data. If the packet is successfully transmitted, then the computer is clear to send out its main data. The term broadcast refers to when there is a single transmitter of data, and that data is being received by multiple receivers. For example, a wireless router can broadcast its wireless signal and be picked up by multiple computers to access the Internet. The difference between unicast and multicast is that with unicast, the data packets are sent to a single destination. And with multicast, the data packets are sent to multiple destinations at the same time. For the Network Plus exam, there are a few routing concepts and protocols that you're going to need to know. And one of them is called a loopback interface. A loopback interface is a fake or virtual interface that is created on a router. It's not a physical interface, it's virtual. And this virtual interface is assigned an IP address of your choice. And the purpose of a loopback interface is for testing and administration purposes. So as an example, let's assign an IP address to a loopback interface on a Cisco router. So in a terminal window, and by the way, you don't need to know all this as far as creating one. You just need to know that for the exam that it's used for administration and testing. So back to our terminal, and while we are in configuration mode, we enter INT for interface, then loopback 0, then an IP address of our choice, and then a subnet mask, and then you're done. A routing table is a file that contains a set of rules that shows information on what path a data packet takes to its destination. For example, a router uses routing tables. So as a data packet arrives at the router looks at its routing table to find out where to forward the data packet along the best path to its destination. So a basic routing table contains a network destination, which is an IP address of the final destination, a subnet mask, which determines which part of the IP address is the host and network portion, a gateway, which tells the router which IP address the data packet should be forwarded to, the interface, which is the outgoing IP address of the device that's sending the data, next hop, which is the IP address to which the IP address is forwarded to, and a metric, and this determines the best route among multiple destinations. If you were traveling to a certain destination anywhere in the world, for example on vacation, most likely you would need directions or a map on how to get there. Well, in the world of networking, it works the same way. In order for data to travel across a network and reach its destination, it needs a map to determine the best path to take. And the way it does this is by using routing protocols. Routing protocols collect information about the current network status and map out the best path for data packets to take to their specific destination. Now, there are three different types of routing protocols. There's distance vector, link state, and hybrid. Distance vector protocols factor in distance to the destination based on how many hops. And a hop refers to how many routers a data packet has to go through to reach its destination. So for example, for data to travel between these two end routers here, it would take 3 hops. 1, 2, and 3. And one of the distance vector protocols is called RIP, which stands for Routing Information Protocol. RIP is the oldest routing protocol. Routers that use RIP broadcast their routing information to other routers every 30 seconds, regardless if the routing information has changed or not. So as a result of this, as networks got larger, this caused a lot of unnecessary traffic on a network. So the developers created RIP version 2, which solved the problem of excessive broadcast traffic that RIP version 1 caused. And another distance vector routing protocol is called BGP, which stands for Border Gateway Protocol. And this is the standard routing protocol of the Internet. It determines routing directions that are based on paths and policies. In addition to distance vector protocols, there is also link state. Link state is a routing protocol that is used by routers to share information and independently map out the best path on a network. Two examples of link state protocols are OSPF and ISIS. OSPF stands for Open Shortest Path First, and this is a routing protocol that is used to determine the correct route for data packets to take to their destination. It collects information from other routers using IP, and it creates a topology map of the network. And another link state protocol is called ISIS, which stands for Intermediate System to Intermediate System. And in this system, the routers are organized into a domain, meaning that the routers are organized into groups. And this is how ISIS primarily functions, is within these domains. And unlike OSPF, where it uses IP to communicate, ISIS uses CLNS instead, which is a connectionless network service. And another type of routing protocol is called a hybrid. And in this case, we're talking about EIGRP, which stands for Enhanced Interior Gateway Routing Protocol. And this is a combination of distance vector and link state protocols, and it only runs on Cisco routers. It is fast, it has less overhead, and it can support many network layer protocols. SIP stands for Session Initiation Protocol, and this protocol is used for establishing communication sessions over the Internet. For example, Voice over IP, which is a term that is used for voice communications over IP networks. It is also used for services such as instant messaging and conferencing. And SIP operates at the application layer in the OSI model. RTP stands for Real-Time Transport Protocol, and this protocol is the Internet standard for transporting real-time data such as streaming audio and video. RTP is often used over UDP, so it doesn't guarantee data delivery. RTP is also used with RTCP, which stands for Real-Time Transport Control Protocol. And this enables you to monitor the quality of the data being delivered. And lastly, RTP can be used to send data in both unicast and multicast. When data is sent across a network, it is not sent as one large piece. The data is actually divided into smaller pieces or data packets, and then they are sent individually. These data packets are sent using two different methods: packet switching and circuit switching. In packet switching, the data packets take different routes to their destination. And once all the data packets reach their destination, they are recompiled into the original message. This method of communication is also known as connectionless. The Internet mostly uses packet switching technology. Now, circuit switching also sends data packets individually, but unlike packet switching, which sends data on different routes, circuit switching does the opposite. In circuit switching, all the data is sent along the same dedicated route. A good example of circuit switching would be telephone lines. ISDN stands for Integrated Services Digital Network. This is an international standard for digital transmission over ordinary telephone lines. In order to use ISDN, users had to install ISDN modems. This was a significant improvement of speed over the standard modem, because a standard modem sends data at a maximum speed of 56 kbps. But ISDN sends data at 128 kbps. But ISDN never really caught on, because of the faster speeds of DSL and cable. T1 lines are probably the most commonly used Internet service for businesses today. It's a dedicated connection that supports data rates of 1.544 megabits per second. A T1 line consists of 24 individual channels that each carries a rate of 64 kbps. Each of these channels can carry data or voice traffic. A T3 line is a high-speed Internet connection that supports rates of 43 megabits per second. It consists of 672 individual channels, and each of these carries a rate of 64 kbps. T3 lines are mainly used by Internet service providers that connect directly to the backbone of the Internet. An E1 line is similar to a T1 line, but an E1 line is the format that is used in Europe for digital transmission. The speed is 2 megabits per second and consists of 32 channels that carry 64 kbps of data. And an E3 line is the European equivalent of a T3 line. It has a speed of 34 megabits per second and has fewer channels than a T3 line. OCX stands for Optical Carrier. These are levels that describe the speed of networks that can be carried on SONET, which stands for Synchronous Optical Network. It's a fiber optic technology that delivers voice, data, and video at high speeds. The OC levels are calculated by multiples of 51.84 megabits per second. These levels are shown on a following table, and you can get the speeds by multiplying the level times 51.84. DSL stands for Digital Subscriber Line, and this is a popular technology that is used by homes and businesses to access broadband data over the Internet. The advantage of DSL is that it can carry both voice and data at the same time. It has a DSL modem that uses common telephone lines to carry its data. It's a high-speed connection that is much faster than your regular dial-up modems. There are a few different forms of DSL, and one is called ADSL, which stands for Asymmetric Digital Subscriber Line. And this is called asymmetric because the download speed is considerably faster than the upload speed. This type of DSL is typically used in homes and is the cheapest form of DSL. SDSL stands for Symmetric Digital Subscriber Line, and as the name implies, the download and upload speeds are the same. This type is typically used in businesses. And VDSL stands for Very High Bit DSL, and this is a very fast form of DSL. It has download speeds of over 50 megabits per second over copper wire. But because it uses copper wire, it's only made for short distances. For long distances, it can also use fiber optic cable. Another popular technology that is used to access the Internet is broadband cable. Cable is by far becoming the technology of choice by many homes to access the Internet. It uses a cable modem with an attached coaxial cable, which provides a link to the Internet service provider. Like DSL, cable is very fast, with speeds of 50 megabytes or more. Cable is typically provided by the same provider that provides cable television to their customers. POTS/PSTN stands for Plain Old Telephone Service and Public Switched Telephone Network. And these are just your plain old telephone lines. And these are slowly becoming obsolete by people who use the Internet because of their slow speeds. So if you have ever used a high-speed Internet, such as broadband, you will never go back to using the slow speeds of 56K, which is the speed of a standard dial-up modem. However, telephone lines do have an advantage, and that is that they are basically everywhere, and they are fairly cheap to use. Satellite communication is pretty expensive, and it's mainly used where no other services are provided, like phones, cable, or DSL. But because of the increasing availability of these other options, satellite is rarely used. The speed of satellite has increased throughout the years, with speeds maxing out around 15 megabytes per second, with only a fraction of that in upload speeds. Another method of connecting to the Internet is by using mobile hotspots. And mobile hotspots are portable devices that use cellular networks to connect wireless devices to the Internet. So if there are wireless devices within 30 feet of the mobile hotspot, they can join it, and then they will have access to the Internet. Mobile hotspots come in two forms. They will either be a freestanding device like you see here, or they can come as a feature built into a smartphone. And mobile hotspots are available through cell phone carriers, such as Verizon, AT&T, T-Mobile, and Sprint. Another broadband internet technology is called WiMAX. And much like your home wireless network, where it covers your home, WiMAX covers much larger areas. WiMAX is basically a super wireless network that can cover entire cities or countries. WiMAX works with WiMAX towers that are scattered in different geographical locations. And these towers directly connect to an internet service provider, typically with a T3 line. Each tower covers a certain area, just like a cell phone tower does. And to pick up the transmission of these towers, you need a receiver in your home or computer to receive the signal, and once that is done, you can now access the internet. WiMAX does have the potential of replacing DSL and cable service because it can provide internet access to places where cable and DSL can't reach. Metro Ethernet is simply a Metropolitan Area Network, or MAN, that is based on Ethernet standards, and it's basically used to connect businesses and residential users to a larger network such as the Internet using Ethernet. Metro Ethernet is fairly simple and cheaper to use because it doesn't require any specialized cabling or equipment like other expensive technologies require. It only uses equipment and cabling related to Ethernet, which is by far the most common internet technology today. So even though end users are not sure what technology their internet service provider is providing in the middle, what matters is that on both ends, it's using Ethernet connectivity. The word PAN stands for Personal Area Network, and this is a type of network that is used on a personal level. It's a small network that is basically used for connecting things like mobile phones, PDAs, and laptops to each other using Bluetooth. PANs are generally used for transferring small files, such as music, photos, calendar appointments, and so on. Now, a LAN stands for Local Area Network. And a local area network is a group of devices, such as computers, servers, and printers, that are basically located in the same building. In other words, in close proximity to each other. The most common type of LAN is an Ethernet LAN, where two or more computers are connected to Cat5 Ethernet cables using a switch. A MAN stands for Metropolitan Area Network. Now, this is a larger network than a LAN. It's a network that spans over several buildings in a city or town. MANs are typically connected using a high-speed connection, such as fiber optic cable. And finally, there is the Wide Area Network, or WAN. And a WAN is the largest type of network. It's a network that spans over a large geographical area, such as a country, continent, or even the entire globe. A good example of a wide area network is the Internet. SCADA stands for Supervisory Control and Data Acquisition. And this is software that is used for controlling and monitoring equipment that is used in industrial facilities such as power plants, water treatment plants, or refineries. SCADA communicates with sensors and systems in real time that are out in these industrial facilities, and those sensors and systems send back information to PLCs, or Programmable Logic Controllers, and RTUs, or Remote Terminal Units, which then sends it to the SCADA computers to be analyzed. And this information could be things like how to reduce waste, or how to improve efficiency, or if there are any problems. SCADA is also often referred to as ICS, which stands for Industrial Control System, which is a general term that encompasses SCADA systems. Cell phones also access the internet and make phone calls by using radio systems such as GSM and CDMA. GSM stands for Global System for Mobiles and is the largest radio system that is being used around the world, including major carriers such as AT&T and T-Mobile, and it's widely used in Europe. GSM works by changing your voice into a digital form, and that data is assigned a time slot. Then, as the data is received on the other end, the assigned time-slotted data puts the call back together. And CDMA, which stands for Code Division Multiple Access, is another radio technology that is not as widely used as GSM, but it's the system that is used by major carriers such as Verizon and Sprint. And CDMA works by data being encoded with a unique key. 4G LTE, which stands for Fourth Generation Long-Term Evolution, is a technology that was developed by the Third Generation Partnership Project. Currently, it offers the fastest wireless communication speed available, with speeds of over 100 megabits per second, which is many times faster than the speed of 3G or third generation. 3G technology offers speeds anywhere from 384 kbps to 2 megabits per second. And prior to 3G was EDGE. And EDGE stands for Enhanced Data Rates for GSM Evolution. EDGE is a painfully slow technology that has speeds not much different than using a regular dial-up modem, with speeds starting around 75 kbps. Remote access service is a technology that enables you to connect to a computer from a remote location. For example, from your home to your job. It allows the services which would be available on a remote network to be accessed over a dial-up connection. RAS was originally developed by Microsoft and built into their Windows NT line of server software, and it works with major network protocols such as TCP/IP, NetBEUI, and IPX/SPX. SLIP stands for Serial Line Internet Protocol. This is a protocol for communication between two computers using a serial connection, such as a typical phone line. But SLIP is rarely used anymore because it's not a secure protocol. During a dial-up connection, it sends all data, including sensitive data like passwords, in clear text. So SLIP falls short because security is a major issue in today's world. SLIP also does not provide any error checking and is limited to using only the TCP/IP protocol. So a better protocol was needed to address these issues, and that protocol was PPP. PPP stands for Point-to-Point Protocol, and this is a standard remote access protocol that is used today. It was developed to replace SLIP's limitation in security, error checking, and protocol support. And like SLIP, this is a protocol that's used for communication between two computers using a serial connection, such as a typical phone line. But unlike SLIP, this is a secure protocol. Most internet service providers use this protocol for their customers who want to access the internet using a dial-up connection. Point-to-point protocol over Ethernet is exactly what its name implies. This protocol uses PPP over Ethernet. It works by encapsulating PPP frames in Ethernet frames. People who use this protocol have a DSL broadband or wireless connection to the internet. It's also used for connecting multiple users on a local area network to a remote site sharing a common device. This is called point-to-point tunneling protocol, and this technology is used for creating virtual private networks, or VPNs. In fact, this is the default protocol associated with VPNs. This ensures that the transfer of data between one device to another is secure by creating a secure tunnel between the 2 points. GRE, or Generic Route Encapsulation, is a protocol that is used with point-to-point tunneling protocol in creation of a VPN network. GRE is what actually creates the tunnel in PPTP. It is used to encapsulate the data in a secure manner. A VPN is a virtual private network. It's a private network that uses a public network, such as the Internet, to establish a remote connection. The data is encrypted as it sends and decrypted when received. It provides a dedicated link between 2 points over the Internet. Now, the way a VPN is created and managed is by using a VPN concentrator. A VPN concentrator is a device that creates the VPN connections and manages the delivery of the messages between the VPN computers and devices. It also authenticates users, encrypts and decrypts the data, and assigns tunnel IP addresses to users. However, VPN concentrators are not always needed to manage and create VPNs. They are mainly used in organizations that are going to use a lot of VPN connections, and they need a device to handle the heavy traffic that VPNs create. If an organization is only going to use a small amount of VPN connections, then they can just use the VPN software that is built into their router or firewall rather than using a VPN concentrator. Now, there are 3 different types of VPN connections, and one type is called site-to-site. And this is when an organization has 2 offices in different geographical locations, and they want those offices to be networked and share data with each other over the public Internet. So they would just need to set up a site-to-site VPN connection, and the VPN will encrypt the data as it goes through the Internet, and then decrypt the data as it enters the organization's private network. Creating a site-to-site VPN creates an alternative to an Internet leased line at a much cheaper cost. Another type of VPN connection is called host-to-site. So, for example, if you're at home with your computer and you needed to connect to your office at a different location so you can access files, then you would need to set up a host-to-site VPN connection. Now, generally, this type of connection doesn't require any additional hardware on your end at home to establish this type of connection. You would basically just need your computer's operating system to connect to your office's VPN hardware. And once the connection is made, then you can access your office's network over the Internet. So all of the special VPN hardware would be on the office or the site side of the connection and not at your home. And lastly, there is the host-to-host VPN connection. And this is simply when you want to establish a VPN connection between 2 computers over the Internet. Now, this type doesn't require any additional VPN hardware at either end. It only requires the software on each computer to create a simple host-to-host VPN connection. Authentication is confirming something that is authentic or true. In computers, authentication is the process of verifying the identity of a user, such as a username or password. In the world of networking, there are several protocols that are used to achieve authentication. So the first protocol we're going to discuss is called PAP, or Password Authentication Protocol. Now this is a very simple authentication protocol. In fact, it's so simple that it's compatible with just about everything. But the downside is that it is not very safe. All sensitive data like usernames and passwords are sent in clear text. Challenge Handshake Authentication Protocol, or CHAP, is a better alternative to PAP because it encrypts usernames and passwords. This protocol authenticates by the server asking or challenging the client to validate itself by using a three-way handshake. So after a connection has been made, the server sends a challenge to the client. Then the client responds by using a one-way hash function with the answer. Then the server checks the response against its own calculation, and if the value matches, then the authentication is passed. Now, MS-CHAP is Microsoft's version of CHAP. There are two versions of MS-CHAP. There's MS-CHAP and MS-CHAP 2. MS-CHAP is basically CHAP, so it only authenticates the client. But MS-CHAP 2 offers mutual authentication. Both the client and the server are authenticated, so it's more secure. Now, Radius is a protocol that enables a single server, such as a domain controller, to handle all authentication. It allows a company to store user access data in a central location. Users log into the Radius server, and that makes the request on the user's behalf after authenticating. Kerberos is an authentication protocol that was developed by MIT, and it authenticates by using tickets. In order for a client to access network resources, it first authenticates itself with the Kerberos server. Then after authentication, the client is issued a ticket, which then gives the client access to the network resources. And EAP stands for Extensible Authentication Protocol, and this is an extension to PPP. It's a general protocol that supports many methods of authentication, and the most common one that it's associated with is smart cards. If you're already a network administrator, then the most common tool that you have probably used is the wire crimper. And this tool is used to make custom length network cables. It crimps adapters such as the RJ45 to twisted pair cables. So after you have attached your RJ45 adapter to your cable, you just place it into the crimper, give it a squeeze, and the cable is done. A punch-down tool is a tool that resembles a screwdriver, and this is simply used to connect or punch wires to a punch-down block. Another network tool is a media tester. So after making a custom length cable using your wire crimper, it's a good idea to test the cable to make sure it's wired correctly. So you would just connect both ends of the cable into the tester, and then the tool will check the cable for you. The plastic shielding around a network cable must be removed in order to crimp a connector. And this is done by using a cable stripper. The cable is then inserted into the tool, and then the outer plastic shielding is removed. A time domain reflector is a piece of electronic equipment used to test cables, such as unshielded twisted pair and coaxial cable. This test is done by transmitting a signal through a cable, and then the signal is reflected back to the TDR. The TDR then analyzes the reflected signal, and from there is able to pinpoint if there are any problems. And these problems include conductors, loose connectors, shorts, crimps, bends, and so on. An optical time domain reflector, or OTDR, does the same thing as a TDR, but it is used on fiber optic cable. Instead of transmitting a signal, it transmits light through the cable to detect problems. A multimeter is a device that is used to test electrical circuits. It's a popular tool that is used for many different trades. It can measure voltage, resistance, current, and continuity, just to name a few. And it comes in both analog and digital versions. A lot of telephone technicians carry a piece of equipment called a butt set. And a butt set is a device that resembles a telephone, and it is used to test and monitor telephone lines. The technician will hook up the device and, as its name implies, butt into a line to hear a conversation to determine if there are any problems, such as noise or something simple like just detecting if there is a dial tone. A voltage event recorder is a device that is used to collect data about the quality of electrical power. The tool is inserted into a power outlet where it checks for electrical sags, swells, and variations in frequency. It comes with software that is installed on a computer, and the data about the power quality is downloaded and analyzed. And this tool is called a tone generator, and this is also known as a fox and hound. Now this tool is used for locating cables from one end to the other. So for example, if you suspect that you have a bad cable that was grouped with a lot of other cables, and that group was stressed over a long distance, it would be very difficult to isolate one end of the cable from the other. So that's where a tone generator comes in. So you just connect the tool at one end, and then it would generate a tone through the cable, where the other part of the tool would detect the sound and pinpoint the cable. A protocol analyzer is also known as a packet sniffer, and this is a software or hardware tool, and this is used to troubleshoot and analyze traffic on a network, such as logs, data packets, broadcasts, and so on. It can detect network problems, intrusion attempts, and monitor networking issues so a technician can correct the problem. A very common software protocol analyzer is called Wireshark, and it can be downloaded for free at wireshark.org. A virus is a harmful program that is written to alter the way a computer operates. Most of the time, users do not know that they have a virus until it's too late. Most viruses are transferred from the internet, such as websites, downloadable programs, and email. If a computer virus is not detected and removed, it could spread and cause serious damage to computers and servers in a network. So that's why today network administrators need to use antivirus software. Antivirus software is the #1 protection against viruses. It's a software program that scans for viruses on your computer's hard drive, targets them, and destroys them before any damage can be done. It is also important to remember to always keep your antivirus software updated. Most updates, if not all, can be downloaded over the internet. In order to maintain optimum protection against viruses, you need to scan your computers on your network on a regular basis. When working on a computer, it's important to not do any damage to the computer components that could be caused by ESD, which stands for electrostatic discharge. And ESD happens when two objects of the opposite charge, such as your hand and a computer part, come in contact with each other. And when this happens, a sudden charge of electricity flows through the two objects. And this sudden charge of electricity can damage computer components. So to prevent this from happening, it's important to wear an ESD wrist strap. By wearing an ESD wrist strap, it can stop the buildup of static electricity in your body by safely grounding you. One end of the ESD strap fits around your wrist, and the other end is grounded. The grounded end can be either attached to the ground pin in a power outlet or clipped onto the metal case of the computer. Another thing you can do to protect against ESD is by using an ESD mat. An ESD mat is typically placed on a desk where assembly takes place, and the mat removes any electrical charge from the components that are placed on it. And just like an ESD wrist strap, an ESD mat is also connected to a ground. When dealing with our environment, it's important to understand what is the proper way to dispose certain pieces of equipment so that it doesn't affect the environment in a negative way. And computer-related equipment is no exception. For example, computers contain lead and harmful chemicals such as mercury that is harmful to the environment. And for this reason, they must be disposed of in a proper way. And if you're not sure how to dispose it, there is a data sheet you can find called the MSDS, which stands for Material Data Safety Sheet. And this will tell you the proper way to dispose that particular piece of equipment. The MSDS will typically be offered by the manufacturer, or you can download a copy of it from the EPA. As a computer technician, it's always important to put safety as a priority when doing any kind of repair work. And if you put certain safety rules into practice, you'll save yourself a lot of time, money, and potential physical harm. So for example, always be sure to turn off the power and unplug the power cable before doing any hardware repair work. This should be your first step before doing anything. This will protect you from being shocked and prevent damage to the computer. Another precaution you can take is to remove any hand jewelry that you might be wearing, such as rings, bracelets, or wristwatches, because these can potentially conduct electricity. Another tip is to always take note where a fire extinguisher is located and how to use it properly in case a fire happens. And in the computer field, a Class C fire extinguisher is what you'll need because a Class C is made for electrical fires. It uses a dry chemical powder to extinguish the flame. Another safety tip is cable management. Maintaining a safe work environment is a major part of any job, and tripping hazards is a vital part of it. So if you have cables running across walkways, you could be in a high risk for a tripping accident. So the quickest way to fix this is to simply relocate any cables that go across any walkway and move them somewhere else. Or if by some reason this can't be done, then you can always use something like a cable manager cover, which neatly organizes the cables in a way where you can't be tripped by them in high traffic walking areas. And another tip is proper lifting. So if you have to lift a heavy object, it's important that you lift the object properly to avoid any injury. You never use your back to lift a heavy object. you always use your legs. So start out with your feet shoulder width apart, squat down, maintain good posture by keeping your back straight at all times, and slowly lift by straightening out your legs. The traditional way a business operates is by using different machines or servers to run different services according to what the business needs. For example, a business would use a server to run their database, another server would be used to run their website, another server would be used to run their email service, and so on. And these servers also could be running different operating systems. One could be running Linux, the other could be running Solaris, and the other one could be running Windows. So needless to say, running a server environment like this can be expensive. Not only do you have to pay for the server hardware, but you have to pay for the floor space, the management, and the maintenance of the equipment. But there is a new trend that is happening in the world of IT, and this is called virtualization. And virtualization is basically consolidating all of these physical servers with their different operating systems and applications and running them on just one physical server in a virtual environment. So now this one server is running all of the different applications like databases, web services, and email, all running side by side on one machine. And not only the applications, but also run the different operating systems side by side. So users that interact with a virtual server would interact the same way as if they were still on multiple physical servers. They won't be able to tell the difference. So needless to say, virtualization saves money. Not only does it save money on hardware, but also on storage space, maintenance, and management. In addition to virtual servers, there are other virtual devices such as virtual switches. And a virtual switch is not a physical switch, but it's a software switch that's created in a virtual environment. So for example, if you wanted your virtual database server to be able to network and communicate to your virtual web server, you can just add a virtual switch to do that. And once the switch is added, then those two virtual servers can now communicate with each other. And there's also a virtual router. And a virtual router performs just like a physical router. It can route data packets between your virtual servers and the internet according to what the business needs are. And lastly, there's a virtual firewall, which is another virtual device that can filter network traffic and monitor that traffic for your virtual servers, just like a physical firewall does. Now the term cloud computing refers to data and applications being stored and run on remote servers rather than being on your local computer. Then this data and the applications that are on these remote servers are accessed and run via the internet. So the workload is no longer on your local computer, it's on the cloud. So back in the old days before cloud computing, and as an example we'll use email. So at your home or office, if you wanted to use email, you would have your own physical email server. So you would have a server and an operating system and email software like Microsoft Exchange. Then you would be able to use email. But the problem is that if anything goes wrong, such as a hardware failure or a software problem, or if the operating system crashed, well then you would be responsible for fixing the problem, not to mention any maintenance that is needed to keep the server running. But now you have the option of eliminating all the hassle and upkeep of your own email server and have a company host all your email on their servers on the cloud for you. Like for example, Hotmail and Gmail. But email is just one example of cloud computing. There are also other services, such as productivity software, web servers, databases, and so on. Now there are three different types of cloud computing. There's Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS. Now these three vary in control and flexibility, so it's up to the user as to decide what suits their needs. So the first one is Infrastructure as a Service. And this type is basically when you're going to let the third-party vendor manage a portion of your business, which is going to be the hardware portion. The third-party vendor will manage the servers, storage, virtualization, and the networking portion. You, on the other hand, will still have control over the software portion, such as the applications, data, operating system, middleware, and runtime. A good example of IaaS would be a web service company like Amazon Web Services. And the next one is called Platform as a Service. And PaaS, like IaaS, allows the third party to manage a portion of your business, but the third party has more control. In a PaaS, the third-party vendor not only manages the hardware, such as servers, storage, and networking, but they also manage the operating system, middleware, and runtime. You are only responsible for the applications and the data. And a good example of a PaaS would be Microsoft Azure, which is a cloud computing platform from Microsoft. And lastly, there's Software as a Service, or SaaS. And this type is probably the most common cloud service so far. All the applications are hosted by a third-party vendor on the internet. There is no software to install on your computer, no hardware to manage. You just simply access and run the application from your computer when you connect to the cloud service via the internet. So the third-party vendor manages all the hardware, software, networking, operating system, and storage. And Google Apps is a great example of SaaS. If you wanted to store data in a centralized location where it can be accessed from all of your other devices on your network, you can do this by using a network-attached storage device. A network-attached storage device is a storage device that is used strictly for storing data. And it doesn't do anything else besides storing data. Typically, an NAS will have multiple hard drives in a RAID configuration for redundancy, and a network interface card that directly attaches to a switch or router so that the data can be accessed over a network. And then once it's on the network, it can be accessed from other devices such as desktops, laptops, and tablets through a shared folder. Now a SAN, or a storage area network, is a special, high-speed network that stores and provides access to large amounts of data. And this network consists of multiple disk arrays and servers that access this data as if it was a local hard drive, because that's how operating systems recognize a SAN. It's recognized as a local attached hard drive rather than a shared drive like on an NAS. SANs are independent of servers. They are not limited or owned by a single server. In fact, multiple servers are attached to a SAN, so all the data is available to all the servers simultaneously. SANs are also easily expandable and they are very redundant, because all the data is shared among several disk arrays. So if a disk array fails, then the data is not lost, because the data will be stored in multiple areas. And as I mentioned before, a SAN is a high-speed network. And that's because in a SAN, all the devices are interconnected using fiber channel, which is a standard for SAN that has network speeds starting at over 2,000 megabits per second. And as an alternative to using fiber channel, there is iSCSI. And iSCSI stands for Internet Small Computer System Interface, which is a data storage protocol that transports SCSI requests over standard TCP/IP. A 66 block is a punch-down block where wires are inserted. The wires are inserted using a punch-down tool, and then they are punched down into the block. 66 blocks are considered outdated and they are not used much anymore. A modern-day punch-down block is called a 110 block. It's better than a 66 block because it can support higher frequencies and use less space. It also meets the standard that is needed for Category 5 UTP cable. A patch panel is a panel that has multiple cable connections and connects incoming and outgoing patch cables in a local area network. It allows network administrators the convenience of arranging or rearranging circuits if necessary. For example, here we have a patch panel that has several UTP patch cables attached. The demarc or demarcation is the point where a customer's network equipment meets with the service provider's network equipment. It defines where the service provider's responsibility for their equipment ends and where the customer's responsibility for their equipment begins. And if the demarc needs to be extended further inside the customer's building, then this is known as a demarc extension. A smart jack is also known as a Network Interface Unit, or NID, and it's often located at the demarcation point, and its job is to terminate the T-carrier's service wires at the customer's building. In addition, smart jacks are used for monitoring a network for errors and connectivity issues. They also have LEDs that indicate errors to a network technician. The term cross-connect refers to points in a building where cables and wires connect together. So a vertical cross-connect is the main backbone that runs vertically and spans between floors. And a horizontal cross-connect is where cables are run horizontally from cable closets to wall outlets. "25 pair is a cable that has 25 pairs of smaller wires inside. The wires are color-coded to identify the individual conductors. Each pair of wires is uniquely colored, giving the cable 25 different two-color combinations. And 100 pair has 100 pairs of wires inside. And these are used for larger industrial jobs compared to 25 pair. Each pair of wires is also uniquely colored to give 100 different two-color combinations. MDF stands for Main Distribution Frame, and this is the main wiring frame that is used as a distributing point for all the wiring in a building. All of the internal lines in a building connect to the MDF, and from there, the external lines connect also, thus completing the circuit. There is also the intermediate distribution frame, and these are smaller distribution frames that are located in various locations in a building, and these provide better flexibility to distribute wires to the main distribution frame. VLAN stands for Virtual LAN. A VLAN is a logical area network that can control network traffic regardless of the physicalities of their location. So for example, let's say you have a 3-story office building and you have different departments mixed in with others on the same floor. Now suppose you wanted to separate the network broadcast activity between the departments from each other, so that the accounting department does not see any traffic from support, support doesn't see any traffic from accounting, and so forth. Now one way to solve this is to physically move the computers to their proper floor and put them on the same subnet with a router. But there is an easier way to accomplish this, and that way is to use a VLAN switch. By installing a VLAN switch, you can logically create several virtual networks to separate network broadcast traffic. So now the 3 departments don't see any traffic created by the other departments. They only see their own. There's also a couple of ways that VLANs can be created. They can be created by ports on the VLAN switch, or they can be created by using the MAC addresses of the computers. An intranet is a private network that belongs to an organization. This is usually an internal website that only the employees of that organization can access. The website usually contains information about the company, for example, company sales, inventory, or history. And this website is also behind a firewall, so no one outside the company can access it. Now, an extranet is similar to an intranet in that they are both private networks within an organization. But an extranet is different from an intranet because an extranet is accessible from outside the organization on a restricted basis. So for example, here we have 2 companies. Company B contains a private network that contains a website with their company's information. Now suppose Company A is a business partner with them and they need to access certain information. So what happens is that Company B will grant Company A access to their website to effectively do business. A bandwidth shaper is used to control network traffic. You can use it to set upload and download limits on less important data, such as recreation. And you can also prioritize important data, like business needs, and make sure that it has the highest upload and download limits. And the term traffic shaping is similar to what a bandwidth shaper does. It prioritizes applications and guarantees bandwidth for more important services. A load balancer is a piece of hardware or software that is used to evenly distribute data activity across a network so that no single server or computer becomes overwhelmed with the workload. For example, here we have a network and one of the servers is getting more network activity than the other server. So to resolve this, we can add a load balancer so that both servers are sharing the network activity evenly. QoS stands for Quality of Service, and in computer networking, this is a term that is used to provide a guarantee of data delivery within a certain period of time. Port blocking is one of the ways to provide security to a network. Port blocking is done on the firewall, and as a network administrator, you can control which ports should be opened or closed depending upon the application. So for example, we learned that FTP uses port 21, HTTP uses port 80, and incoming email uses port 110. These ports need to be open if these services are to function. But what would happen if we were to close some of these ports? For example, port 80 and port 110. If we close these ports, then our network will not be able to receive any web pages from HTTP or email. But since we kept port 21 open, then FTP functions normally. So port blocking can be a great way to keep your network safe, but it can also cause problems if you mistakenly close the wrong ports. And high availability is a term that is used to guarantee a period of uptime of continual operation. In order to keep a network in constant operation, you need to make sure that it always has power. But unfortunately in our world, this doesn't always happen. Power outages can happen for several reasons, such as storms and blackouts. So in order to prevent a disruption in network operation from a loss of power, you need to use a UPS. UPS stands for Uninterrupted Power Supply. It's a battery backup that supplies power to your equipment if a power outage were to happen. So as an example, if we were to disconnect the AC power from this computer, the computer will remain on because it's connected to a UPS, and it is now running from battery power from the UPS. In addition to supplying backup power, UPSs also protect against surges and spikes. Link redundancy is having the ability to have a continuous connection to the network in the event of a failure. So for example, if you are using a broadband connection, you can have an ISDN line as a backup if the broadband line were to fail. Or you can also have a secondary network card by having one as a primary and the other as a secondary. So if the primary card were to fail, the secondary card would automatically kick in, so you would still have a continuous connection. There is also backup services, and this could be defined as having backup servers to keep your network in constant operation. For example, a standby server. A standby server is a secondary server with the exact configuration as the primary server. Now this server is not actually being used, but its data is constantly being updated with the primary server. So if something were to happen to the primary server, the standby server would immediately take over. And another type of backup service would be server clustering. And server clustering is when a company has a group of servers used for load balancing and fault tolerance. In this setup, the servers would share the workload if one of the servers fails. And this type of setup works best if the servers were in different geographical locations. So if some kind of natural disaster were to happen at one location, it would not affect the other servers. Fault tolerance can be defined as the prevention of data loss if a network component fails. But in the event that fault tolerance fails, then disaster recovery would be our last option. Disaster recovery is the process of rebuilding an organization's data after a disaster has happened, such as data loss. So even if we implemented fault tolerance measures, we still need to back up our data. There are 3 different types of data backups: full, incremental, and differential. In a full backup, all the data is simply copied and backed up into one tape. So as you might have guessed, this is the simplest form of backup because only one tape is used. And if you ever needed to restore the data, then that one tape is all you would need for restoration. But let's say your organization has a large amount of data, then performing a full backup daily would not be efficient, because the disadvantage of using a full backup is that it takes the longest to perform. Which brings us to our next alternative backup method. Now in an incremental backup, the only data that is backed up is the data that has been changed since the last full or incremental backup. So for example, let's say you have a company that does a full backup on a weekend and does incremental backups Monday through Friday. The only data that is copied to tape is the data that has been changed since the last incremental backup, which is each weekday. So Monday will only copy Monday's data, Tuesday will only copy Tuesday's data, and Wednesday will only copy Wednesday's data, and so on. So as you can see on this illustration, each backup tape only copies the data that was changed for that weekday. Now the way an incremental backup knows which data has been changed is by what's called an archive bit. This bit informs which files have been changed since the last full backup, and it clears the archive bit when the backup is done. When you have to restore an incremental backup, you have to restore the full backup along with the incremental backups, and you have to restore the incrementals in the same order as you back them up. So for example, here we have a full backup tape and a week's worth of incremental backups. We'll go ahead and restore the full backup tape first, and then we'll restore the incrementals from Monday through Friday in the correct order. And now we have a full restore of our data for that week. In a differential backup, the data that is backed up is the data that has been changed since the last full backup. So going back to our example, a company does a full backup on the weekend and does differential backups on weekdays. As data is being added to the database each weekday, the differential backup will back up the data that has been changed since the last weekend full backup. So Monday will copy Monday's data, Tuesday will copy Monday's and Tuesday's data, Wednesday will copy Monday, Tuesday, and Wednesday's data, and so on. So as you can see on this illustration, each backup tape copies data not only from their own day, but also from the previous days as well, since the last full backup, which was done on the weekend. The differential backup also uses the archive bit, but it's important to note that when a differential backup is done, it does not clear the archive bit. Now after a differential backup, if you ever needed to restore the data, the procedure is that you would need to restore the last full backup and the last differential backup to completely restore your data. Offsite storage is where you can back up your data and have it stored on a different geographical location for safety purposes. So for example, let's say your main office is in Miami, and you chose to have an offsite storage database in New York. If some kind of natural disaster were to happen in Miami, let's say for example a hurricane, and your main office was destroyed, you would still have a copy of all your data in New York where it is safe. Now a hot spare is defined as equipment that can be swapped out without the need of turning off the power. So for example, if you had a server with multiple hot swappable hard drives, and if a hard drive were to fail, you wouldn't need to shut down the server. You would just simply remove the hard drive and replace it with a new one while the power is still on. Now a cold spare is similar to a hot spare, but with a cold spare you must turn off the power first in order to replace the piece of equipment. IPsec is a set of protocols for security at the network layer of the OSI model. It encrypts the data when communication is happening between two computers. But in order to use IPsec, both sender and receiver must share a public key. This key is what locks and unlocks the data that is being communicated as it travels across a network. This ensures that the data cannot be read or tampered with. In addition to encryption, IPsec also verifies the data to make sure the data is received exactly as when it was sent. And IPsec also has two modes, transport and tunnel. In transport mode, only the message portion of the data packet is encrypted, but in tunnel mode, the entire data packet is encrypted. Layer 2 tunneling protocol is a combination of Cisco's Layer 2 forwarding and point-to-point tunneling protocol. And this protocol authenticates in two ways using digital certificates. It authenticates both the computer and the user, and it does this to ensure that the data is not tampered with during the authentication process, which is known as man-in-the-middle attack. SSL, or Secure Socket Layer, is the protocol that is used to ensure security on the Internet. SSL uses public key encryption to secure data, and it's commonly associated with HTTP. So for example, if you were to go to an e-commerce website, you will notice that an S has been added to HTTP, which indicates that you are now using SSL in your web browser. And SSL provides protection in three ways. It authenticates the server, the client, and it encrypts the data. Transport Layer Security is the latest industry standard SSL protocol. It's the successor to SSL, and it's based on the same specifications. Like SSL, it also authenticates a server, client, and encrypts the data. And TLS is made up of two layers. The first layer is the TLS record protocol, which provides connection security by making sure the connection is private and reliable. And the second layer is the TLS handshake protocol, which allows the server and client to authenticate each other and negotiate an encryption algorithm and cryptographic keys before data is sent out. And the goal for TLS is to make SSL safer and more secure. And our last security protocol is 802.1x. And this standard is used for both wired and wireless networks. And it controls network access by ports. So if authentication passes, the port is opened. And if the authentication fails, the port is closed. Next, we're going to talk about SOHO routers, which stands for Small Office Home Office Router. And these are your common inexpensive routers that are used in homes and small businesses. These are fairly easy to set up, but if you don't configure the router correctly, you will not have access to the network. To set up and configure your SOHO router, you need to go into the router's built-in configuration web page. So you would just open up a web browser, and in the address field, you would type in the router's IP address. So for example, our router has an IP address of 192.168.2.1. And once you type that in, you press enter on your keyboard, and now you're in. So here's an example of the configuration page for a Cisco SOHO router. And this is where you would set up the router with custom settings to make it work for your particular network. So for example, like most SOHO routers, this one has a DHCP server built into it. And as you recall, a DHCP server automatically assigns an IP address to each computer on your network because all computers need an IP address to function on a network. So by default, the DHCP server is enabled. But if you want to, you can disable the DHCP server by pressing this button here, and then just save your settings. Also on the router's web page, there are the wireless settings. Now in here, you can configure the wireless settings for your network. For example, you can set the SSID, which stands for Service Set Identifier. which is basically the name of your wireless network. The SSID is shared among all wireless devices in your network. The SSID is customizable, and you can call it whatever you want. And as you can see here, this SSID is called My Wireless. So as an example, when a wireless laptop scans for wireless networks to join in the vicinity of this router, the laptop will see the router's SSID broadcast called My Wireless, and if it has the proper credentials, it can join the network. Also in here, you can set the channel for your wireless network. And channels are used to avoid interference with other wireless networks nearby. So if you are experiencing any connectivity issues to your wireless router, there might be interference with another nearby wireless network that's operating on the same channel as yours. So in this case, you can try changing to a different channel and see if it solves your problem. And if you click on the Wireless Security section, you can configure the security of your wireless network. So here you can choose to disable security and have your network wide open, or you can choose to secure your network with one of these security modes. And as you can see, this router supports the following security options, such as WEP, WPA, and WPA2. Wired equivalent privacy is one of the security protocols that are used for wireless networks. And as its name implies, it's meant to supply the same security to wireless networks as it did for wired networks. But this turned out not to be the case. After time, it was found out that the 40-bit encryption key that WEP used was not secure and it was easily hackable. So a better security protocol was needed for wireless. WPA is another wireless security protocol that was developed to solve the security problems of WEP. WPA is far better than WEP in two ways. First, it uses a stronger encryption method using TKIP, which stands for Temporal Key Integrity Protocol, which dynamically changes keys as it's being used. This ensures data integrity. And secondly, WPA uses EAP, which verifies authorized network users. Building on the security of WPA, WPA2 was developed to provide even stronger security than WPA. And it does this by requiring the use of a stronger wireless encryption method. While WPA uses Temporal Key Integrity Protocol for encryption, which has known to have some limitations, WPA2 uses CCMP for encryption. And CCMP is more secure because it uses an enhanced data cryptographic encapsulation mechanism. And since 2006, WPA2 is available on all certified Wi-Fi hardware. And our last wireless security protocol is WPS. WPS stands for Wi-Fi Protected Setup. And this security protocol was designed for users who know little about wireless networks to make it as easy as possible for them to join a secure wireless network. So here's an example of a WPS configuration page for our router. And as you can see, there are 3 different WPS methods that you can use to join this wireless network. So you could use method 1 if your client has a Wi-Fi protected setup button. You would just press that button, then within 2 minutes you would press the WPS button here on this page, or you can just press the physical WPS button on the router itself, and then you'll be connected. You can also use method 2 if your client has a WPS PIN number. You would just enter that number in here and press register. Or you can use method 3 if your client asks for the router's PIN number. and you would just enter this number into your device, and then you'll be connected. So as stated before, WPS is the easiest way to join a wireless network, and a lot of manufacturers are building their wireless products with WPS to make it as simple as possible for their customers to join their device to a wireless network. Another wireless security is the MAC filter. Every wireless adapter has a MAC address. A MAC address is a hexadecimal number that uniquely identifies each device on a network. And with the MAC filter, you can either prevent or permit access by using the device's MAC address. So in this example, once we enable the MAC filter, we can choose the option to prevent devices that are listed below from accessing the wireless network. So all of these devices listed here are now blocked from joining the network. Or the other option, we can choose the permit option, and this will allow only the devices listed below access to the network. There is also what's called the DMZ, and DMZ stands for Demilitarized Zone. And the DMZ allows a designated computer on your network to be fully exposed to the internet. And it does this by the router forwarding all ports at the same time to the designated DMZ computer. So while these computers here on our internal LAN are protected inside the firewall, the DMZ computer is outside the firewall and is not protected. The DMZ is typically used for testing purposes. So if you just set up a computer that you want to be accessed from the internet, and if you're having a problem configuring the firewall and applications so that it can be accessed from the internet, you can simply bypass all firewall security and put the computer in the DMZ temporarily to make sure everything is working until you can pinpoint a problem you are having, such as a firewall setting. It's also important to note that the DMZ computer must be assigned a static IP address and not automatically from a DHCP server. Another option on the configuration page is port forwarding. And on this page, you can customize port services for certain applications. So when a user sends these types of requests to your network from the internet, the router will forward those requests to the appropriate computer. So for example, let's say a friend of yours wants to access one of your computers in your home network using RDP or Remote Desktop Protocol. And as you know from an earlier lesson, that RDP services uses port 3389. So what happens is, when your friend starts up their RDP service on their computer, they put in the public IP address of your router, and once that request hits your router needs to know which computer on your network to forward that request to, so your friend can access the correct computer. So that's where port forwarding comes in. Here on the port forwarding configuration page, you have to forward the RDP port to the correct computer. So you type in the RDP port number, which is 3389, and then you have to point it to the IP address of the computer that you want your friend to access, which is 192.168.2.3. And once that's done, the router knows where to forward that request, and the connection is now complete. A feature that's built into most wireless routers is called a guest network. And a guest network is a separate wireless network that's built into a wireless router that your guests can join so they can have access to the internet. The guest network will have its own SSID, and it's typically the same name as your main network SSID, but by default may have a -guest suffix added to the SSID. The ping command is the most widely used of all network utilities. It's a tool that is used to test issues such as network connectivity and name resolution. So for example, let's go ahead and ping a host IP address. So at a command prompt, you would type ping space, then the IP address, and then press enter. Now it's going to send out 4 data packets to the destination IP address we chose. Then the destination will send the data packets back to us as a reply. And these replies are called echo reply requests. And these replies will inform you about what's happening with the destination host we pinged. For example, if we received a reply, then that means that there is general network connectivity between us and the destination. But if we did not get a reply, then that means that there is no reply from the host, and it could mean that there is no network connectivity between us. But if we pinged the host, and we get a message that says request timed out, then that could mean that the host is down, or that it's blocking all ping requests. Or after we pinged, and we get a message that says destination host unreachable, then that message is coming from a router, and it means that a route to the destination cannot be found. The ping command can also be used to test DNS name resolution issues. For example, before we used the ping command with an IP address, but we could also use it with a domain name. For example, we could type ping space, then the domain name yahoo.com. So if by pinging the domain name, and if we got the same successful result as typing the IP address, then this would indicate that the name resolution by DNS is working fine. But let's just suppose that the domain name ping failed. Then the next step will be typing the IP address instead. So if by typing the IP address, and if the ping was successful this time, then we now know that we are having a problem with DNS. The ping command can also be combined with other subcommands called switches. And switches are used to alter the parameters of the ping utility. And you can view a full list of these switches by typing ping space / and then a question mark. And PathPing is another Windows network utility that combines the functionality of ping and traceRT. So at a command prompt, just type in pathping and then the IP address or the domain name, and then press enter. And the pathping output shows the details of the path a data packet takes between 2 devices, and it also gives ping-like statistics for each device that the data packet takes on its way to its destination. If you wanted to check a device using the regular ping command, and if you fail to get a response because the firewall on the device has blocked all ping requests, you can use the ARP ping command instead. The ARP ping command uses ARP data packets to ping network devices. And since it uses ARP packets, a firewall will not block any ARP data, because ARP data is never blocked or should be never blocked on a LAN. And the ARP ping command cannot be used on the internet. The data is not routable, so it only works on a local area network. Our next utility is called traceRT, which stands for trace route. And this is used to find out the exact path the data packet is taking on its way to the destination. So for example, let's go ahead and trace the route from our computer to another computer. So at a command prompt, we would type traceRT space and then the IP address and press enter. Now the data packet will find its way to the destination, and each time it reaches a router on its path, it will report back information about that router, such as the IP address and the time it took between each hop. So the TraceRT utility is a great tool that can be used to pinpoint where a problem lies on a network if a data packet cannot reach the destination. So for example, if we try to ping a destination and the ping command failed, we can use the TraceRT utility to find out where the data packet is failing along its path. So let's go ahead and trace route this IP again. And let's suppose that this time there was a problem. So let's type in TraceRT, then the IP address, and as the data packet goes on its path, it'll tell us at which area the problem lies. And the data packet stops right here. So the TraceRT utility has isolated that the problem is somewhere between these two routers. And this is the MBTstat utility. And this is used to resolve NetBIOS names to IP addresses. So at a command prompt, just type in NBTstat, and here is an example of the result. This is probably the least common utility that you will ever use. And our next utility is called ARP. And as you might recall from an earlier lesson, ARP is used to resolve IP addresses to MAC addresses. In order for a computer to communicate with another computer, it needs to know the MAC address for that computer. So the first thing the computer does is check its ARP cache to see whether it already has the MAC address for that computer. In fact, we can check this ourselves at a command prompt by using the ARP utility by typing ARP with a -A switch. And as you can see, it has no entries at all. So now it will ask the computer with the corresponding IP address for its MAC address. And once it has the MAC address, it will store this information in the ARP cache. So let's do the same command as before. And now you can see that the IP address and matching MAC address have been added to the ARP cache. So the ARP utility is a good way to manually check which IP address is associated with a certain MAC address. Our next utility is called NetStat. Now this is a very useful tool, and it's used to display current network connections to your computer. So in our example here, we can visually see that our computer is currently communicating with an FTP server and 2 HTTP web servers. And we can verify this by using the NetStat utility. So at a command prompt, we type NetStat, and in this case we're going to use a -A switch, and then press enter. Now in our display, we can see the 2 HTTP servers and the FTP connection. So even if you're not sure what connections your computer currently has, you can use the NetStat utility to find out. And in addition to connections, it also displays which ports are open and listening for a connection. The ipconfig utility is very common. This utility is a powerful tool used to display network configuration for our computer, and this information can be used for problem solving. So for example, if we open up a command prompt and type in ipconfig along with the /all switch, then this will display the full TCP IP configuration for our computer, such as our computer name, MAC address, IP address, default gateway, which is the router, DNS servers, and so on. And by using this information, we can find solutions if we are experiencing problems. For example, if we had a problem with our IP address, we can see from this information that DHCP is enabled, which means that this computer is getting its IP address from a DHCP server. And it also tells us the IP address for the DHCP server. It also tells us the IP address for the DNS server, so if we're experiencing any problems browsing the internet with domain names, then there might be a problem with the DNS server itself. Using the ipconfig utility by itself displays the IP address, subnet mask, and default gateway. But using this utility when combined with subcommands called switches changes the output slightly. So for example, when we use ipconfig combined with a /all, which we just used in our previous slide, it displays the full TCP IP configuration for our computer. When we use ipconfig /renew, this releases and renews the IP address lease given to us from the DHCP server, and ipconfig /release releases the IP address but does not renew it. To see a complete list of all the switches that can be used with ipconfig or any command utility, just type in the name of the utility, space, and put a / and a question mark. And that'll show you all the switches that are available. And similar to the ipconfig utility that's used in Windows, there is also the ifconfig utility. And the ifconfig utility is a command that's used in Unix and Linux operating systems. And it displays configuration information from the network interface card, such as the IP address, subnet mask, how many packets it has received and sent, any errors, and so on. And like ipconfig, it can also be combined with switches on the end to alter the output. And our last utility is called NSLookup. This name is short for Name Server Lookup, and this utility is used to look up DNS information. So for example, at a command prompt, if you type in NSLookup along with a domain name such as yahoo.com, the result will give you the DNS information for the Yahoo domain. And the dig command is the Unix version of NSLookup. It does the same thing. As far as the way a network is designed, there are two main types, wired and wireless. Networks don't have to use one or the other solely, but they can also be combined. In fact, if you have a wireless network, at some point there is a wired connection. Most businesses today use a combination of wired and wireless networks. So it's important to understand as a network administrator how to diagnose problems related to wired and wireless issues. And one of those problems is media. And in a wired network, this involves copper cables. And over time, cables can be worn out or damaged, and that's when shorts can happen. It's also important to remember to use the right type of cable depending on what kind of network you're using. For example, if you are using copper cabling, it's important to recognize the environment around the cable, because certain electronic equipment, such as fans, fluorescent lights, or air conditioners, can interfere with the copper media and therefore altering or reducing the strength of the signal, which is known as attenuation. And another factor is the length of the cable. If the cable exceeds the maximum recommended length, then this could also cause a problem. Or if you are using the wrong type of cable, this can also affect your network. For example, if you are using a crossover cable when you should be using a straight cable. Antennas are another factor that affects a wireless service. Since the wireless devices operate using radio waves, the antenna is a big factor that can determine the range and speed of a signal. One type of antenna is the omnidirectional antenna, and this happens to be the most common type as well. This type of antenna transmits the signal in all directions. So every wireless device in all directions can pick up this signal as long as they're in range. And another type of antenna is the directional antenna. And this type directs the signal in one direction. And that direction is wherever you point the antenna to. There are also problems that can arise in a wireless environment. And one of these is interference. Microwave ovens can cause interference, and certain wireless devices can interfere with a wireless signal, such as cell phones and Bluetooth devices such as a wireless keyboard and mouse. The waves that are produced by these devices can alter the signal of a wireless network. And a cordless phone is another device that can interfere with a wireless network. And that's because a lot of cordless phones operate at the same frequency as wireless routers do, which is at 2.4 gigahertz. In fact, I had a situation one time where one of my customers was complaining that every time her phone rings, she would lose internet connection on her laptop. And this is because her cordless phone and her wireless router were using the same wireless channel. So to quickly resolve this, I just logged into the router's configuration page and changed the channel on her wireless signal, which quickly solved the problem. And also the structure of a building is another factor that can affect a wireless signal. Depending upon the structure of the building, like concrete walls, window film, and metal studs, can all affect wireless signals. So in this case, you may have to consider where you are placing your wireless router to avoid these kinds of structural interference issues. So you may have to test out certain areas in your home or office to make sure that all your devices can use your wireless network. And using the wrong type of encryption could also prevent wireless devices from joining your network. For example, if you're using a later wireless encryption method, such as WPA2, on your wireless router, but if you're using an older laptop that can only use WEP or WPA, well then that laptop wouldn't be able to join the wireless network because you're using a later encryption method that your laptop cannot recognize. Similar issues can happen in fiber optic networks as well, such as signal loss or attenuation. Other factors include using the wrong type of cable, wavelength mismatches, fiber type mismatches, dirty connectors, connector mismatches, bending the cable too much, and exceeding the cable length limitations. Problems can also happen in DHCP. For example, what would happen if a DHCP server was removed? If this were to happen, then certain computers that have an expired IP address would not be able to renew their IP lease because there is no longer a DHCP server present. So these computers won't be able to access the network. This would also affect when new computers are added. They will not be able to access the network without an IP address. It's important to remember that this is only the case if the computers were configured to obtain an IP address automatically. So this would have no effect if they were configured for a static IP. So in another scenario, what would happen if another DHCP server was added to the network? So it's important to remember that if you're going to add another DHCP server to the network, that it must be configured properly. For example, you're going to have to make sure that the two DHCP servers do not give out the same IP address to a computer, because all IP addresses must be unique. And if the second DHCP server assigns an IP address that is already in use, an IP address conflict will happen. So to avoid this, you must configure the address pool correctly. Problems can also happen in DNS also. And as we discussed earlier, DNS resolves domain names to IP addresses. The main impact that this service would have on a network if DNS was not working properly is basically accessing web pages using domain names. For example, yahoo.com would be resolved to the IP address 66.94.234.13 by a DNS server. But if a DNS server was not present, you would not be able to access the Yahoo website using the domain name yahoo.com. You would only be able to access the Yahoo website by typing in the IP address instead. Link LEDs are very simple indicators that are used to tell us basic information about a network device. For example, on a network interface card, if you were to plug in a network cable, you would notice that the green LED turns on. The green LED is called the link light, and this indicates that there is a successful network connection. However, if the LED does not light up after a cable is plugged in, then this indicates a problem, such as a bad cable or something simple, such as maybe the computer is turned off. The blinking yellow LED, on the other hand, indicates that there is network activity happening. Whether the blink rate is medium or slow, this indicates normal operation. Another thing, and probably the most obvious to check, is physical connectivity. Is your computer connected to the network? If it is the link LED on the network card turned on? Or is the cable that you are using good? So if you don't see the link LED and you know that the cable is good, then you might want to check the switch. Is the switch even turned on? Are there any LEDs on the switch? And you might also want to check if the network cable is loose on either the NIC or the switch connection. And then there are certain procedures for solving network problems. And here are some of the steps to do that. So the first step is to identify the symptoms and potential causes. This step is where you gather information about the problem, such as what exactly is the problem, when did the problem occur, were there any specific error messages, and does it happen all the time or intermittently? So by gathering as much information as possible in the beginning, it'll greatly enhance the diagnosing process and ultimately fixing the problem a lot faster. And the next step is to identify the affected area. So a good question to ask is the problem isolated at one particular location, or is it spread across several locations? So for example, let's say that everyone on a LAN cannot access the network. So one of the first places to look would be the switch, because we all know that all computers connect to this single device. And if this device was not working properly, it would affect everyone. Or what if the problem was isolated at one particular computer? Then in this case, we would not check the switch. But a good place to start is that we would check the cable and connection for that particular computer. So when this step is done correctly, it will dramatically cut down on the diagnosing process and save a lot of time. So after you identify the area, the next step is to establish what has changed. Problems don't occur at random, they happen for a reason. So the next question to ask is, did anything change just prior to the problem happening? Was there any hardware removed or added? Was there any software installed or uninstalled? Or did the user download anything? And the next step is to select the most probable cause. So try to keep this step simple. Always look for the simple and the obvious solutions before digging deeper. For example, see if the computer or device is even turned on. Check to see if the cables are plugged in. check the simple LEDs, and you'll be amazed how the simplest solutions will fix most network problems. And the next step is to implement an action plan and solution including potential effects. Now this step is the cautious phase. So before taking any action to solve the problem, you must know what effect this will have on the network. For instance, if you were to take a device offline, how will this affect the rest of the network? By doing this, will this disrupt everyone else or be isolated at one area? And the next step is to test the result. Now this step is where you actually take action to solve the problem. This is where you will know if your plan of action has solved the problem or not. And after you test the result, the next step is to identify the results and effects of the solution. Has your plan of action solved the problem or not? And if it has, what effect did it have on everyone else? Do the results show a temporary fix or a permanent one? And the last step is to document the solution and process. Now this step is a very important one. Now that the problem is solved, it's very important to document the problem and the solution so that if it ever happens again, you or anyone else will know not only how to solve the problem as fast as possible, but also to take preventive measures so that the problem will never happen again. So the things to include in the documentation are the problem itself, what actually caused the problem, and how did you fix it. So by following all these steps carefully, you can be assured to diagnose and solve problems effectively as a network administrator.